Well, good morning, everyone. Greetings and welcome to everyone that has joined. This is the webinar which focuses on modern silviculture technologies. My name is Muedanyi Ramantswana, and I am a lecturer at the Nelson Mandela University, which is based at the George campus in South Africa, and specializing in forest engineering. This is now the fourth consecutive year that we are running this webinar, and the need for this platform has grown as developments in this field have increased over the years. As proof, recently at the Expo Forest in Brazil, which occurred in August, we were able to see about 6 purpose-built planting machines, which is indeed a good indicator of where the focus in the forestry landscape is shifting to, where it was traditionally focused on modernizing and mechanizing harvesting operations. Today's webinar is going to be focused on the theme of optimizing modern silviculture. And we are very glad that we got a very good response of over 350 participants who registered for the event by yesterday. Our audience is diverse and coming from different countries across the globe. So despite the differences we have in practicing silviculture because of the different prevailing conditions, this webinar has attracted both local as well as international people. Even though a majority of our audience is from South Africa, we have representation from across 21 different countries. And if we look at neighboring countries such as Zimbabwe, Swaziland, all the way to Uganda and Ghana, and if we look at South America, we have countries like Brazil, Uruguay, and Chile. In Northern America, we have countries like Canada, and as well as in Europe, where we have countries like Portugal, Latvia, Sweden, and the United Kingdom. Furthermore, we have other countries that are also represented, such as Sierra Leone, Pakistan, as well as China, just to mention a few. The participants that have registered for this webinar have different occupations, foresters, contractors, silviculture specialists, academics, researchers, students, as well as consultants, and as well as machine manufacturers. My hope is that this webinar will be able to help us build on existing knowledge and help us to engage, as well as stimulate ideas for innovation, but more importantly, build relationships and connections both locally and internationally to help us further develop this field of modern silviculture. So to officially commence with the webinar, I would like to call upon Prof. Chentu, who is the Deputy Dean from the Faculty of Science at the Nelson Mandela University, to do his welcoming address. Thank you, Prof. Chentu. I hand over to you.
Thank you so much, Dr. Ramantswana. Can you just confirm if my screen is
yes, it's visible. Yes.
Thank you. Thank you again for this opportunity to welcome attendees at this important webinar. And of course, we are pleased as this university to host this webinar in this very specialized area of forestry. I gathered as I was reading around it, I had not come across this terminology of silviculture often in my life, but I kind of understood that this is a very specialized area of forestry, which deals a lot with technology around what is used in this area of forestry for harvesting, etc., and planting. So mine is really short, is to welcome your colleagues as they engage here for this more than half a day or so web seminar. So obviously we are not in the same cities as this university. I'm sitting in what is now called Gqeberha, which is Port Elizabeth, and George is just southwest of that. If you can get a sense of where we are, we're probably separated by about 350 kilometers or so. And of course, George, this particular cluster in George, which has forestry, nature conservation, and Agricultural Management falls under the Faculty of Science at Nelson Mandela, which I will introduce in a moment. But I just thought I would just put a few considerations that are probably important as you discuss, because the demands have grown, and in terms of wood product, what is projected has significantly increased, so which puts pressure, of course, on this industry. And of course, you are faced with issues of digitizing, AI and automation in your industry, because it's quite labor intensive. So those questions come to the fore. And of course, you're also faced with questions of training your future foresters in this area so that they are ready for this future of work. And of course, as Dr. Ramantswana has described, that the business landscape is always changing. So I thought, of course, you are quite green in your outlook already, but I mean, of course, there are other areas that you could contribute to in terms of greening the economy. I also think of the types of fuel that probably your machinery use are probably not of a green source as well, but I mean, one could easily get engaged in other transdisciplinary studies to ensure that this area continues to green itself all the way to the kinds of fuel that they use. Because I mean, wood, you can produce biofuel quite readily. It's just the type of wood and the kind of oil one can get for it and further process. So I would like to challenge you as you go along to continue to green other sectors of the economy as well, instead of just focusing on the processing of wood for use as a solid wood. So I just want to introduce you a little bit to a little university, which is now just struggling to.
Does seem we lost, it's muted now.
Okay, I just could not move the slides, but they're okay now, I'll fix them. I just wanted to introduce a little bit. Right, so of course we're a multi-campus university, and where some delegates would be in person in this campus here, which is in George, and there are various campuses in Port Elizabeth, and I am based in a South campus, which is the one on top, which is also a nature reserve, which is demarcated in yellow there. Of course, our very first campus was in the city, which was a satellite campus of Rhodes University before it was converted into the University of Port Elizabeth. That's just our brief history. It's a very, very long history. Problem still exists. I think I will just leave them on. Of course, in terms of numbers in the university, we sit around 32,000. I think I will just leave them in this form because it's not working on the PowerPoint form. We're about 32,000 students or so across 7 faculties, and a small proportion, about 6%, are international students. And just as a faculty is quite focused on pure and applied sciences. That's the nature of who we are. And we therefore envision that we wish to be an engaged transdisciplinary African faculty of science that responds to socio-economical and environmental challenges in society. So your discipline fits quite well with where we would want to be as a faculty of science at Mandela. And the particular, of course, cluster that you are visiting today, which has forestry is based in George, as I've mentioned before, and there's 3 departments there, which is agriculture, conservation management, and forestry. And of course has a very productive sustainability research unit, which contributes significantly to questions of sustainability. Just in nature of programs, of course, George also engages in some of these diploma programs. So we run both diplomas, which of course at George, once we have crossed advanced diploma level, we can get through to honors and then masters and PhD. So we cover quite a full scope of programs since we're a comprehensive university. And we also cover degrees, of course, in various disciplines of science, all the way to PhD as well. Just for you to have a sense of where we engage in research, we have themes that are sort of quite accommodative of everybody. We are also quite strong in marine sciences, hence we have an ocean campus, but we engage in questions of global change, biodiversity, environmental stewardship. So you all fit right in here with all these questions, as well as, of course, innovative technologies is where you want to pitch your discussion today. So our cluster at George fits right into these research themes. We also engage quite significantly with society because we want to be a university in service of society. If there was time, but because I have lost a bit of time, I would have played one of these YouTube videos for you to see what we do with communities. So I thought I would just play with those 3 legs of learning and teaching. As a comprehensive university, we run diplomas and of course the sciences as well in terms of Bachelor of Science. Research, we are also quite engaged and tackling very good themes there, and we are also quite engaged with communities, industries, etc., etc. This would have just been a highlight of what we do. So without wasting a lot of time, I've looked at the program. It looks rich in terms of attempting to deal with these issues of automation and digitizing your industry. So I can commend you for that. And of course, you come from many different countries, so we do welcome you here. It is really an international webinar, the way I see it. And I just want to wish you luck as you deliberate on these hard questions today. And well done to Dr. Ramantswana for putting together such a webinar. And I thank you.
Thank you, Prof. Chentu, for the welcome. With those words, we are able to start off this webinar, welcomed and well positioned to be able to engage further regarding silviculture modern technologies. What we are now going to do, I'm going to just give an overview of the theme with a brief detail. And then we will start with our first presentation. So just to introduce the theme, if you have observed or followed various technology trends across the globe over the past several years, you may have noticed that the new technologies have emerged, and they are of course changing the way in which we practice silviculture from a traditionally very manual intensive, manual orientated type practices to now more modernized, wherein we have semi-mechanized type systems as well as fully mechanized systems, more especially when it comes to tree planting. We do understand that soil preparation has been advanced for some time, wherein mechanized systems have been introduced, but because of the complexity of planting, we have seen not very much development in the past. Now, every day we are becoming more accustomed to the reality of these ever-increasing technology trends, such as automation, digitalization, artificial intelligence, robotics, and augmented reality. And what you will notice today is that some of the speakers will touch on some of these issues as part of new technology that we are using, It can be in nurseries or in actual planting equipment, soil preparation, as well as any nurseries and other value chain activities. So these technologies are growing and they are being adopted because of the need to improve efficiencies, as well as reduce cost, as well as to improve safety, amongst other reasons. So regarding this theme of optimizing silviculture technologies, the question we need to ask ourselves today is, are we making the best use of the existing resources that we currently have available? Are we optimally using them? This can be in terms of the human resources, the materials that we might be using in silviculture, such as seedlings, chemicals, and ultimately, if we are able to optimize the use of the resources that we have, and we are able to have good stewardship, we then are able to ensure an industry that remains sustainable, viable, as well as competitive. Today, we will listen to 8 interesting presentations. The first 4 will focus on more local activities with reference to Southern Africa. The local presentations are focusing on interesting developments on issues such as residue management, spraying, planting technology developments in silviculture. The 4 international presenters from Brazil, Netherlands, Sweden, and as well as Finland will focus on nurseries, planting machines, as well as digital technologies that can be used for managing silviculture operations. These type of knowledge sharing platforms are quite important, and they not only provide us with information, but they open up our minds to the opportunities that exist and stimulate our minds to rethink the way in which we do things, with the goal of improving as well as refining our forest practices. And my hope is that we are able to engage with our speakers beyond just the general question and discussion sessions today, so that we can be able to improve. So please note, as we go into the program, that we have broken up the webinar into the 2 sessions, which is, as I indicated, more Southern Africa focused. And then we will have a Q&A session. Then we will take a brief 15-minute break, then resume to complete the remaining 4 presentations, which have a more international focus. Then we will conclude with a Q&A session after that. So before each presentation, I will briefly introduce the speaker, then hand over to the presenter to deliver their presentation. We do have the Q&A session, which you can we will engage in at the end of the 4 presentations. However, we do have the chat wherein, as the presenters present, you can be able to put your questions directly to a specific presenter, and then during the Q&A questions, we will engage in those questions. Each presenter has 15 minutes to present their content, and we will be able to then go across all presenters within the specified time. So please take note, we are at the mercy of technology. Sometimes there are some technical glitches which may occur as we are presenting from different locations across the world. So please bear with us if anything does occur. We've had several dry runs to make sure things run smoothly, but unforeseen things do happen, and we will make an effort to get that resolved as soon as possible. We have our IT technical team that is ready and as our backup to help us with those things. So the webinar will also be recorded. So once the webinar is completed, you can contact me directly, and we can be able to share the recording of the webinar with you. So shall we start with our webinar? So this morning we are going to start. Our first presenter is Zimbili Sibiya, and Zimbili is a final year PhD forest operations candidate at Stellenbosch University, and her focus has been on improving operational efficiency for small and medium timber growers. So she holds a master's in forest and wood technology science, specializing in forest operations, that is more economics orientated, and a Bachelor of Science in Forestry and Natural Resource Management Science from Stellenbosch University. Zimbili possesses a wide range of core skills as well as competencies, including research, interpersonal communication, project management, and people skills. They have been recognized for her leadership excellence, receiving the Stellenbosch University Rectors Award and achieving second runner-up in the Stellenbosch University FameLab Science Communication Competition. Zimbili's participation in local and international conferences and summits reflects her commitment to staying updated with the latest trends in the field. She has presented research at other conferences such as the COFE FOMEC, as well as the International Umoja Inauguration African Student Leadership Network Summit, among other places. So Zimbili, we are looking forward to hearing your presentation, and I'm handing over to you as you're going to be presenting on the pathways to modernization, bridging research, technology, and stakeholder needs in silviculture. You can unmute and present. Thank you.
Thank you very much, Muedanyi, and good morning, everyone. Sorry, I just noticed that I was sharing the wrong screen, so I'm just going to fix that quickly. And good morning, everyone. Thank you for the opportunity that I'm being provided with to share some of my learnings and curiosities. Now, I do need to give a full disclaimer that this is part of my PhD work, and not all results are clear yet. But what I'd like to do with my presentation today is to tickle your brain a bit and get you to think a bit more beyond what we've been doing so far. So, okay. Now, I like going back to the definition of words that we use. And in one of the 2020 modernization webinars that was hosted by Muedanyi as well, one of the speakers defined it as modernization can be an ergonomic, safety, or technical intervention, ranging from a better hand tool to a fully mechanized operation. And this is the introduction of machinery to an operation as part of modernization. And I think it's important to remind ourselves about these definitions because they do help us understand the context in which we are having these conversations. But what I also wanted to include is what a pathway is. Now, we can easily associate it to what we are used to, which is a trail or a walkway. But in the context of our work, and especially this presentation, it's a way that is specially designed for a particular use. And if you think about modernization and what we include in modernized equipment or the development thereof, is we want to design something specifically for a particular use. And in our context, silviculture operations. And I also want to share this quote by Ramantswana in response to the reason why that webinar was started in back then, is that we have seen the introduction and adoption of new technologies by local stakeholders, which were driven by various reasons, such as the need to increase productivity and to reduce cost. However, even though silviculture has left us behind for several years, there is growing interest both locally and internationally in our innovations in this field. And for me, when I started my PhD, in our, the holy harvesting handbook that we have, there's a section that describes what appropriate harvesting operations are. And one of the descriptors that they use is these operations must be silviculturally agreeable. But what made me wonder is what would that now look like in the context of silviculture operations? And unfortunately, I couldn't get a clear definition or a clear answer to that, but it did make me think further on. Knowing what the main drivers of modernization are, these give us different paths in which we can explore on how we can improve it and optimize the opportunities we get. So mostly wanting to modernize as a forecast, but also the ergonomic risk because forestry is a dangerous occupation, and safety and health of the people that are involved in it, productivity, the environmental impact is becoming an increasingly huge drive as well, and then employment. And I think one of the thoughts that I'd like to plant in your head is when we think about the word modern, is it should be something that is today in our current context. So in our current context, employment is becoming a huge drive. And even though people don't always come in the forestry industry, especially like the field workers, to enjoy the field work, like they don't choose working in the forest as a first option. They come because they need jobs. So then from our side is we need to then decide how do we use what is available in terms of technology and modernize our work, the work methods, the tools that we use to fit our context. Now, context being that our industry is not the most lavish for a lot of people, especially the field work, but we do have control over the kind of equipment we introduce to our communities, or at least like in our operations. And then the one question that I added is, but don't communities also drive how we modernize? And the reason I ask this, I'll explain in part of in the next slide. But to just leave that hanging, this is a photo that I extracted from one of Ramantswana's studies. And essentially, they were just demonstrating what the current status of modernization looks like in terms of silviculture operations. Now, it is on site, tree planting and stand tending, excuse me. But then what I found interesting is we have evolved so much and the potential for the automated one. But who is being left behind? And at the same time, where do we draw the line exactly to modernize within the context of our status, especially in South Africa? And what can we use to meet the needs that we want to meet in terms of modernization drivers, and at the same time, make it appropriate to our context, which is we have low employment rates and we are struggling economically, but we still want to keep our industry alive. And not to mention that some of our challenges are coming from the communities in which we work in. So these are important for us to take into account. Now, with my study then, we actually were driven mostly by the reality of the current context is there are a lot of land claims currently happening in South Africa. And unfortunately, even though we have all these different supporting structures, we are in this position where we need to start thinking long term, because the land ownership is shifting. And it is shifting towards inexperienced people in terms of like timber owners. And then it puts us who are already in the industry and have markets at risk, because then we lose land space, which means we're also going to lose resources, which are the trees, because if you can't plant it on the land, then it's a problem for us. So we need to now think ahead in terms of what is the potential land ownership profile and how do we meet them halfway, and meeting them halfway in terms of technology, but also just how do we take the modern context and think about the future, but apply the real needs to the current status based on what is available and feasible. So we worked with NCT, and with NCT mostly because they, as a cooperative, they support a lot of private owners and at the same time small and medium scale timber growers. So we felt that it would be a great opportunity to understand from the stakeholder perspective, what are the needs, and in their context, how do we meet the different sized timber growers, and how do we ensure that our investments in research actually aligns with what they need. So the first part, this is still in the process of being studied. We're busy with interviews, but this is a Delphi study that we initiated with the intention of understanding if there is strategic alignment within the cooperative, especially considering that one of the strategic intentions are associated with appropriate technology. Now, the stakeholders we wanted to include, or at least the participants, are the people from the high managerial positions, like the board members. And then we also wanted to know insight from the managers and the estate managers. So these are the foresters that do the work every single day. And one of the questions that we wanted to ask them in terms of the definition of appropriate technology is whether they agree with this technology. I mean, with this definition. And this definition comes from an old study by Grobelaar, and it was done in the context of South Africa. And he defines appropriate technology as a spectrum of basic, intermediate, and highly mechanized technology that is evaluated for a specific situation along agreed upon social, environmental, and economic criteria with the intention of supporting sustainable development. Now, I can't share all the outcomes of this yet, but one of the key changes that we are observing so far is that there's been a huge shift from just focusing on the economic criteria, but the priority is shifting towards the social and the environmental impact. And I think this is important for us to take into account because even from a market perspective, the people who are buying our products take into account the profile of where that product comes from and how the people who were involved were treated, or at least the work conditions and the environmental impact. And even though we need the economic criteria to be impactful, or at least have a boost, we are more likely going to benefit if our markets can see that we prioritize the social and environmental aspects of this. So this for me was quite interesting because we also engage with the participants, and so they completed a questionnaire and they gave their inputs in terms of how they see this definition, whether they agree with it, but also what do they take into account when they think about indicators that would be aligned with appropriate technology. And then they also got to rate based like literature-based indicators that we found and then put together, and to just rate how important they think they are in terms of making decisions for silviculture operations with the intention of meeting appropriate technology needs. So what we then did after that analysis, so we are currently in this phase, and this is where the interesting findings are coming in, because the timeline is also indicating that when they initially completed the questionnaire, it was during COVID. And then after, now that we're doing the interviews and they're reviewing the inputs, there's been a lot of shifts. And in the ratings, what we are seeing is the prioritization, or at least rating the social aspect more important, merely because of how they saw the impact on the communities during both COVID, but also the looting in July that shifted the perspective of some of the foresters. So I found this quite interesting because we do want to improve and stay, competitive, but our context in South Africa right now is putting us in a space where we really need to work with the spectrum of technology when we say we are modernizing, but also for us to optimize the people that we have and the resources that we have. So what we then did after this is we also did an analytical hierarchy process study, because obviously for my PhD, I can't study everything. But what we wanted to do here is we wanted to find out from them what operations do they want to prioritize in terms of research needs. And mostly because we have a lot happening in harvesting and we have enough going on. But with silviculture, the foresters are the ones that I engage with the operations every single day. So they see things that we don't always see, and we can get from them what do they truly need us to invest our energy and input in. So what we did then is we asked them to rate each indicator, each operation as follows. So these are the operations they rated against each other in terms of which one is most important. And then we did publish the work on this, but what we also wanted to emphasize is that while the process that we used, it is a very popular decision-making process, but what we also found is, as I think people that are part of this industry, and especially institutions, is that we also need to help our industry in knowing where to go to for certain research needs. Yes, they do know, but like if you look at the specialties within each institution, it would be much easier for people to know where to reach out to get certain research needs met, instead of us having to, yes, they are willing to fund a person in that space, but then do the people have the means to address the situations that they want addressed as stakeholders? So what we then concluded with were the one operation that they wanted to prioritize. It's the harvest waste management. And the reason for that is because of how they really want to move away from the burning of operations, but also take into account that especially the Midlands area, the terrains are quite steep. So they have a lot of steep slopes where most machines don't function well. So then there's a need to rethink how do we do harvest waste management with the intention of reducing our environmental impact. And then what we also looked into were the soil preparation and planting methods. Now, I'm not going to dive into this part now. I just want to share one of the opportunities that I think is worth exploring when we think about modernizing and optimizing our current status with in terms of the technology that's available. So with pitting, this is a study that we piloted. And if we think about pitting operations, so we know why we want to pit, because we want happy plants and then we want them to grow well. And then we've seen the developments. There's great technology advancement in these operations. But the reality is we are still very much manual in our country, especially with the small timber growers, because obviously they can't afford these big machinery. And it is on us then to ensure that we can at least understand our work better, but utilize the new technology to go back and see what are the opportunities to improve. So the reality is the manual equipment is preferred merely for economic reasons, and the labor intensiveness of it requires people to do the work. So there's increased job opportunities, and it has a lower environmental impact. But the concerns is it's long hours, and the terrain conditions makes it even more difficult for people to work there, and people tend to do task chasing, which increases the work speed, and then it just makes the work a lot more difficult. And we already know that it's ergonomically unfavorable. But what we were curious about is with the current resources that we have, especially in Stellenbosch, what can we understand better with what we already know, and then how do we contribute with the new technology? So if you think about our muscles activation, so when a person exercises, we get excited because the muscles are sore and you are growing muscles, so it's a great thing. But sometimes that pain is an indication of there's too much happening that is unpleasant in the muscles, and then it is causing very, very unpleasant pain to the people that's been doing the work. So we know the whole back pain issue. Now, what we wanted to understand is which muscle groups carry the most strain during manual pitting, and then which equipment has lower risk for work-related musculoskeletal disorders. So we used what is called EMG, which is electromyography equipment, to understand muscle activations when a person is doing work. So we can see which muscles are active and then what part of the body is most compromised. Now, with the IMU data, so this is more of the anatomical angles and the orientation and how far they deviate from the manual plane. And this just gives us an indication of if the operator is bending like this. So we're able to calibrate the skeleton to this person. And then we are able to see that even though we know the person is flexing, we can actually quantify the degrees to what extent they are flexing and how long do they stay in that posture. Now, the equipment was unfortunately expensive, but it was a trial, and I feel that the more we actually utilize this high value data, because there's a lot of data points, the more we can actually understand how people individually experience these different forestry work. So we had one of our students do this, and then the sensors were placed on them. And what we compared were these 3 tools. Now, this tool here is well, that's a crowbar. I think you are aware of it. And then this is the normal road pick. I'm aware of the time, Muedanyi, I'm going to wrap up soon. And this is it was a hoe that we asked to be just cut, and like the edges here have a couple of teeth. And as a new tool exploration, but also with the design here, we wanted to make the handling of the tool a bit smoother to hold. So when we then tested it, we also looked at the different times where the person swings to lift. So we measured that. And then when they pit, but also the moment where they wiggle. This is when they try to obviously get the tool out of the soil and make the hole. So we eventually, wait, this is a mistake. Am I going back? Sorry, my slide is cutting itself and I'm not sure why. Okay, we should be here. So what we eventually managed to see is how different the muscles engage. So in this case, we could see like on the upper tracks that the right side engages a lot more than the left side when using the pickaxe. But what was interesting is with the glutes, because these are very important to reduce the risk of lower back issues, is that they are equally engaged, somewhat equally engaged in the activities, which also then raises the question of what is happening in the skeletal then, because we already know that this causes a lot of back issues. And then we looked at the crowbar, and the crowbar, because of its design, it forces the operator to utilize most of the right side of the body, or the dominant side. And you can see here on the lateral dorsal side. So these are the lat muscles. And there's a huge spike, like major differences in the right side compared to the left, which is also then an indication of concerns, because that means the person is going to be affected only on one side, and they're also going to overwork one side if they use this tool. But what was also interesting is also with the middle deltoid, like even though the left engages, because they require to lift the tool up, they also engage a lot more of this one compared to the left side. But what we noticed with the single-handed hoe is that it is a light tool, so that makes a difference. But also because it uses one side and not both sides, there's huge spikes on the right side. But what was interesting is with the lower back, the glutes, and the semi-tendons, which are, where are they now? Some of the lower back muscles, is that it's actually not too much variation in terms of the left and right side, which gives an indication that the strain on the muscles is not as intense. So when we look at these muscle activations and the differences, it helps us understand that which tool should we actually utilize with the interest of not compromising the one side of the person's body, but try to look for more bilateral type of activities. And then what we could conclude so far is that the non-bilateral muscle activations are a huge concern first because of the tool design. And then with the dominant side experiencing the highest load because the person's using that side the most. But what we also know is that the middle deltoids in all the 3 equipment have a lot more engagement, which makes sense because that's how the person works. They need to lift it consistently. But where we had less muscle activation was with the crowbar. So sorry, in the lower back was with the crowbar, and mostly because the person barely had to bend with the crowbar due to the length and height, and that they could use the force and weight of the crowbar to add more strength in digging. And the main concern is the extreme flexion of the lower spine, simply because they naturally have to bend. Now, I touched on this one specifically because it's exciting technology that is not necessarily used in our context, but it is new technology that we can start using to understand our experiences better and our operations better. Wow, I want to also thank the people that have sponsored me and for also supporting my studies. And if you have any questions, please do ask. That slide is not supposed to be there. Sorry, people, but it ends here. Yeah, I'm going to hand back over to you, Muedanyi. And I think the main thought that I want to leave you with is what else is not a major thing in our discipline that we could get from other disciplines to understand our context and operations better, taking into account the current status in our country and whether it's appropriate for us to adapt with these other modern options. Back to you.
Right. Thanks very much, Zimbili. Thought-provoking things that you've mentioned that we can be thinking of, and just an encouragement to our attendees that we do have the chat that you can pose questions to the specific presenters, and then we will engage during our Q&A session. On that note, we are going to proceed so that we are not too behind on time. And now I'm going to introduce to you Mr. Henny Zita. He holds a diploma as well as an advanced diploma in forestry that he obtained from the Nelson Mandela University. He is currently doing work for the university as a part-time lecturer, and also he worked at Fort Cox on a part-time basis, presenting some modules such as forest product processing. He's currently pursuing his BSc honors in the School of Natural Resource Management, majoring in forestry, and he also compiles and is involved in for Silvitech as an editor, and he's also a tutor at the Department of Forestry. He is going to be presenting some of his work, which is titled The Performance and Effects of Harvesting Residue Treatment Methods and Subsequent Survival in South African Pine Plantations. Henny, over to you, and we're looking forward to your presentation.
Morning. So thanks, Doc, for the introduction. I'm just going to share my slide. Yeah. I hope everyone can see my slide.
Yes, the slides are visible. Thanks, Henny.
Okay, yeah. As introduced, my name is Henny Zita, and I'm a fifth-year honor student here at Nelson Mandela University. And today I'm going to be presenting a study titled The Performance and Effects of Pine Harvesting Residue Treatment Methods in South Africa, supervised by Dr. Muedanyi Ramantswana and co-supervised by Dr. Raphael Spinelli. In today's presentation, I'll be looking at now the introduction, give an overview of the research goal and objectives of the study, touch a bit on the methods and materials, and then I'll discuss the results. Thereafter, I will conclude. So, around the world and in South Africa, forest plantations are intensively managed to produce products such as pulp and paper and other wood products that are out there in the market today. And due to the increasing population in the world, the FAO has predicted that the wood product demand will increase from 2.3 to 3.1 billion cubes between the year 2020 and 2015, which we are in that era as we speak. So that brings us to the significance of silviculture and forestry, as it plays a crucial role. And it is important for us to understand that every operation or practice that we do in silviculture is done correctly because it has long-term impacts such as survival, long-term impacts on things such as survival, growth, uniformity, and the ultimate yield of the stand. So residue management is a key component in forestry. And just to put it into context, there was a study that was done by Dr. Muedanyi Ramantswana and other researchers. It looked at the South African re-establishment methods, and it used a survey. So it gave an overview of the residue management methods that are used in South Africa. And with that, it estimated that burning was the most used residue management with 78%, and followed by broadcasting with 11%, and then mulching as 8%. So with that, the lack of information relating to modern residue management methods led us now to conducting this study. So as mulching is a new practice that is being introduced in forestry. So we came up with 3 objectives and a goal, which aimed to determine the performance of 3 methods for dealing with harvest residue on pine stands. So with that, we aimed to assess now the 3 residue management, being the manual, semi-mechanized, and full mechanized in terms of productivity. And then we also assessed now these 3 methods in terms of work quality and the cost associated with that. And also we assessed these methods in terms of survival and early tree growth response of the Pinus eleuteri plants growing different sites, being now the broadcasted and the mulch site. So now taking you through the materials and methods of the study, I would like to initially orientate you of where the study took place. It took place in South Africa, in the Eastern Cape province, in one of MTO's plantations, compartment D57B, in the Lutheran area at Tsitsikamma, with the effective area of 10.41 hectares, and the volume realized per hectare was 1,031.15 cubes per hectare. This compartment was harvested using the fully mechanized harvesting system with the cut-to-length harvesting method. So for any project to go out accordingly, one needs a plan. So we came up with these 8 investigative steps that we followed. So initially we selected now the compartment that the study had to take place, and thereafter we measured the compartment to see how many plots we can fit inside that compartment, and then we pegged out the plots in lengths of 30 by 150 meters long. So after that, we assessed now the biomass. As we got there, the residue arrangement was in piles. So we had to choose 2 representative piles that we assessed in terms of branch wood and stem wood. And so with that, we used now the white bags, as you can see in picture number 4 there, to measure the weight so that we can get the biomass of now that is left inside each plot. So after that, we assessed the productivity studies for the equipment that we used, and thereafter we used the 1 by 1 meter square grid now to get the work quality after each method that was used. Thereafter, we observed the pitching and planting of the seedlings inside the compartment. After that, we now assessed the plant growth using a ruler and a caliper to get now the diameter and height of those seedlings growing there. So this is a layout of the compartment and how we pegged out the plots from plot number 1 here and then to plot number 12, as we replicated the methods that we used 4 times. So as you can see, these are now the residue piles inside each plot that we now assessed. Looking at the methods and specifications, so as I indicated, we used 3 residue management methods, being the manual, semi-mechanized, and full mechanized. This one just is a combination of broadcasting and thereafter tractor mulching on top of now the broadcasted residues, and this is the fully mechanized using now the purpose-built mulcher with their specifications. So for data analysis, we firstly got the descriptive statistics so that they can lead us to which appropriate statistics we can use for further analysis of the data. Then we use the software Statistica software package to analyze now the data of productivity and the work quality using the Mann-Whitney test. And then for the cost, we used the SAFCA costing model, which we firstly now needed inputs. So we contacted now the machine manufacturers and the contractors to get now the inputs so that we can put them in the SAFCA costing model to derive the cost of each method that we used. So for now the growth and survival, we used the GenStat software package now to analyze the data of growth using the one-way ANOVA. Looking now at the results that we got from this study, the descriptive statistics indicated that the stand characteristics of the compartment, the plots that we had our methods in terms of hectares, residue, piles, residue load, ODT, and the stem mode were quite similar for now the three methods that we looked at. And when we look at the productivity results, it was found that the purpose-built mulcher, which is the fully mechanized method, had the highest productivity, doing 1.43 hours per hectare, and the least productive method that we observed was the semi-mechanized, obviously semi-mechanized residual management method, doing 17.58 hours per hectare. When we get to the cost, we found that the purpose-built, which is the fully mechanized, was the one which was most expensive, with 4,083 rands per hectare, and the least expensive method that we observed was the broadcasting only, which is the manual with 400 rands. When we look now to the residue breakdown by method, it was found that the fully mechanized method had its residue broken down to lengths below 20 centimeters in length, followed now by the semi-mechanized and the fully mechanized, with theirs more in the lengths between 20 and 50 centimeters. And just to put it out there, work quality is subjective. So depending on the goal of the compartment that you're doing the residue management on. So when you're looking at the height growth of the seedlings after now the methods after now the planting have occurred, it was found that in the 6 month and the 12 month the seedlings grow much in height in centimeters for the manual method compared now to the semi-mechanized and the full mechanized, with the full mechanized having less growth when compared to the other two. So now the ground line diameter, which is the diameter of the seedlings when you use the caliper. When using the interquartile range as a measure of dispersion, it was found that the tractor mulcher, which is the semi-mechanized method, had more varieties in the 6 month and in the 12 month. So there were more varieties in the diameter growth of the seedlings growing in the semi-mechanized method. When we're looking at the survival, we found that the fully mechanized had most mortality when compared now to the semi-mechanized and the fully mechanized and the manual, with the two, which is semi-mechanized and manual, having now less mortality in their thing. So in conclusion, today we looked at 3 residue management methods, being manual, which is manual broadcasting, semi-mechanized combination of broadcasting and a tractor mulcher, fully mechanized, which is now the use of a purpose-built mulcher. Then we looked at these 3 things in terms of productivity and cost, the work quality, and growth and survival of now the seedlings planted in those plots. So it was found that the manual took more time, as well as the semi-mechanized took more time, but the manual being cheaper than the semi-mechanized, which now was expensive, and the full mechanized, it took less time, and it's a good operation in terms of productivity. However, it's expensive. When looking now at the work quality, it was found that the manual method had least work quality, because now the breakdown of the residues, and then the semi-mechanized had the moderate quality in terms of that, while the fully mechanized method had the best quality in terms of work quality, in terms of breaking down the residues. And when we look at the growth and survival of the first year, we found that the semi-mechanized and the manual method had average mortality in their plots, which now we regarded them as a good treatment for these seedlings, and then the full mechanized having now the highest mortality, and then being regarded as the worst treatment in terms of growth and survival. So I recommend that more investigations must take place to investigate the impact of work quality, to determine how much of the additional cost incurred with mulching is recovered through more efficient replanting. Also, we recommend that researching on the tractor and the purpose-built mulching on other species residues such as eucalyptus and acacia stands. Also, we recommend that research could also look at alternative methods of dealing with slash other than burning and mulching, which is now we can do biomass harvesting for energy production. So these are my references that I used. So I would like to acknowledge the Nelson Mandela University for giving me this opportunity to study at their institution, and also MTO for now allowing us to conduct this study in their land, and also the contractors and Saviti for allowing us to now do this study on their machines. And I would also like to thank my supervisor for the continuous support from the start of the project until the end, and my family and friends for now the support, emotional support that they've given me throughout my study. Thank you. That concludes now my presentation.
Thanks, Henny, for that presentation. And interesting results. Of course, this is based on a single site here in the Western Cape. And there are some questions that are coming through, and we are going to be able to deal with them and respond to them during the Q&A session. So I would like us to proceed and move on to the next presentation. This morning we are going to have a presentation by Mr. Mbekiseni Nsele, and he is going to be presenting on advanced weeding with the Trono weeding tractor. Just a little bit about Mr. Nsele is the following. He holds a BTech degree in forestry and a BTech degree in business administration. He has over 17 years of forestry experience, and he basically started working as an assistant harvesting forester at Siakubega Forest, and was promoted to a harvesting forester a year later. And he has been managing manual, semi-mechanized, fully mechanized, as well as cable yarding operation during that period. Mr. Nsele has also held the position of senior silviculture forester at Siakubega Forest, and worked as a silviculture forest manager for Mondi in the Mfolozi area. He has also held a position of a deputy director in the planning and audit department of DAF, being responsible for enumerations, strategy, and technical planning, plantation evaluations, as well as auditing DAF plantations against PCI and S set by the government. Currently, He holds the position of Operations Manager at AMA 38 Trading, and he has been vital in implementing modernized silviculture operation, including the highly productive Trono sprayer. Mr. Nsele, we are looking forward to your presentation, and I hand over to you.
Thank you, Doctor. Good morning, everyone. See if I can share. Can you see my presentation?
Yes, it's visible. If you can just put it on slideshow.
Okay, good morning again. Thanks, Doctor, for this opportunity. A brief about AMA 38. We are contracted to Mondi and SQF, Siyakhuluka Forest, which is a subsidiary of Mondi. We do silviculture we are based at Kwambonambi. We do silviculture from here up to Mtunzini, for those who know the area. And we do maintenance of about approximately 20,000 hectares per annum and plant about 1,500 to 2,000 hectares. About the Trono sprayer, well, the background is that because of modernization, it led to different approach to silvicultural operation. I think you would have seen from Zimbili's presentation that we had a lot of manual operations, and all our operations, site prep, planting, the pre and post canopy operations also needed to change. And as AMA 38, we needed to a realignment of our operations to fit into the bigger Mondi modernization strategy. So we started with the planting and went on to our weeding. And in this case, I'll talk about the chemical or the herbicide spray. And our journey started when we went and looked for machinery. And on the right, you will see a tractor that has a boom sprayer. And we had one of those units. It was not giving us enough. And we went and checked to the people who have been doing modernization or who have been modernized or are very well advanced with technology than forestry. And that is agriculture in South Africa, because they are more collaborative than we are in forestry. And we went and looked at that one beautiful machine. Unfortunately, it costed about 5 million rands at the time. So it wasn't economically viable for us to get that machine. Then we found the Trono sprayer. The Trono sprayer is a tractor-drawn boom sprayer. It's got an adjustable boom with a 2,300 liter tank capacity. The boom is 18 meters long, and it has about 36 nozzles. Your swath on the boom will depend on the nozzles that you use at the time. And it weighs about 1.7 tons, pulled by a tractor. And it has that self-leveling mechanism, because you all know that in forestry, if you drive around, it's not as flat. And it can either be hydraulic or PTO driven. One of the reasons to look for a unit like this is that we work in the Zululand coast, and it is as flat as a table. I think about 90% to 95% of our area is about 0 to 15% steep. So we needed something that can work there. We are just lucky because it's not that steep. On the side of the unit, you will find an adjustable pressure mix with a 30-liter herbicide mixing container. We'll come to that later in this presentation. We currently have 2 of these units. We use the Landini tractors. There's a Landini tractor and the Kubota. The Landini is about 125 kilo. So it's a 86 kilowatts, and the Kubota it's 70.8, 71 kilowatt tractor. And inside the cab, the driver can see a computer screen, which also is fitted with the GPS. And if you look at the top slide, at the top picture, it will tell you that there's the last job that he would have done. That the plus is when he needs to start a new job, and you can save the job in our case, we prefer that to be a compartment. So while the driver is driving, inside his cab, he can see the speed that he's traveling in, and the computer or the GPS will then adjust the herbicide and the water that you're putting down. You set it to spray the number of liters that you want. In this case, on the bottom picture, you will see that we had been spraying about 300 liters of water mixed with herbicide per hectare. It shows the pressure that you're using, which you adjusted, and also the water, the overall amount of water that you would have used. Where's the pointer here? But that 744 on the bottom picture is the number of liters that he had used on the day. So what we did on this picture, we stopped the tractor. That is why you can see at the traveling speed is 0 kilometers per hour. So he had sprayed about 2.5 hectares on that day. He had used about 744 liters, and unfortunately you couldn't see the pressure. And it also shows the nozzle, and he also has the boom switches, those buttons that you can see on the top picture. It shows him the hectares that he has sprayed, where the herbicide has been applied. So if you look at the bottom picture, there will be green area, there's a shaded area which is like grayish. That is where he had sprayed. Who can make this thing? And that is where he had sprayed. Where it shows orange, it's where he would have overlapped and sprayed, but the toner sprayer switches off automatically, so you don't waste water, you don't waste herbicide. So if the tractor goes over where he has sprayed, the nozzles would shut down automatically and then spray the other side of the boom. It also shows in the nozzle type. That is shown on the top picture. I think it's the bottom left, where it says USI 100 or US 100. Currently, we have a 9-hour shift where we use this machine, and we use the AV 110 nozzle, which is an air induction nozzle. So what it does is it brings air in and makes the drops a little bit bigger, so that it minimizes the drift of the herbicide. And we only use it for full cover spray, which would be our temporarily unplanted areas, which we are going to stay for some time, for pre-planting, where we use glyphosate. And we also use it for applying the selective herbicides, where we spray the grasses and the broadleaf. So how the operation works is, before planting, we destamp every 6th row for excess. And the operations that follow after that would be our semi-mechanized planting. It also makes it easier for us to spray with the toner sprayer and run it on in those compartments, because they're flat, and the destamping helps with the excess. For implementation and efficiency, on the side of a sprayer, there is a container where you pour in your herbicide. You then calibrate it, and using the pressure that you need to apply for your herbicide to put it down onto the weeds. And then the picture on the right depends on your timing. The timing of this operation has to be really good. The picture on the right then shows a 2-week-old coppice, that it's a eucalyptus coppice that had been sprayed by the toner sprayer, and it seems to be very effective. However, if you don't get your timing right and your coppice starts to grow a little bit high, you may get poor results. So timing, like all the silviculture operations, is of importance. We've done a couple of studies. This one was done by Mondi, which we are contracted to. And as you could see in that study, I'll summarize it. At 7.5 hours, the productivity of the machine, a shift, was about 32 hectares. At that time of the study, we had a lot of stops and goes, and we've perfected the operation now. It should be doing way better than this, but what is evident is that as the rows get longer, the sprayer, the unit seems to be more productive. You also need flat areas. I'm not sure if it will be productive as here if you were to apply, or if you use the same operation on steeper areas. So our productivities came out at 5 hours, came out in 602 meters long row, came out at about 4.8 hectares per machine hour. And then at 2.5 hours, it was about 3.9 hectares, and on average, this operation was doing about 4.5 hectares per productive machine hour. This was then compared to other productivity studies that had been done, and some of the sprayers that were there. There was a semi sprayer, there's an AF sprayer, and a jack sprayer, and a drone. In all these units, the Trona sprayer seemed to be the most productive. We have to add that this was in flat areas here in Zululand, and it works to our advantage because it's flat. So we faced a couple of challenges with this machine. At first, we had the problem with the refilling times. What we have done now is to put in a bulk tanker, which has more water flow. So if you look at the tank, it's 2,300 liters. If you can get a pump that will pump, and the pipes or the hoses that will pump about 1,000 liters per minute, it will shorten your refilling times. Row length plays a big role in the productivity of the machines because it drives longer. And then the turning times, the shorter the row length, you will turn more. So you spend more time turning instead of driving and spraying. So that reduces your productivity. There's also challenges with undulating ground conditions, because then the boom tends to be not as level. Then our herbicide application and coverage on the ground is not the same. But there are opportunities. If we can match our compartments and make them bigger and longer, then we get our productivities right. We've also looked at block spraying, where we fill a huge block of compartments, and instead of spraying one compartment at a time, you align your compartments and spray 2 or 3 if possible. We've looked at the extended shift hours or double shifting. This will mostly depend on the weather. If it's too windy or it starts and it gets a little bit better during the day, you can then double shift or make your shift slightly longer, especially in summer months. The increased tank capacity, that one will help you to refill fewer times. So if you've got longer rows and a bigger tank, the chances of productivity is going even higher than where we are now would be high. And then the other opportunity is real-time data sharing. We've looked at it in a way that a forester should be able to get information from the sprayer while it's spraying in field. We did try to match the GPS software on the tractor with the Mondi GPS software with the maps. It bombed out for now, but then we need to keep trying so that we can get information as quickly as we can, so that we can manage our operations better and get a better understanding. That should be all from me. I will wait for the Q&A. Thank you. And thanks, Doctor, again for this opportunity to present.
Thanks very much, Mr. Nsele. Very interesting work that you are busy with there, innovative, and we will look forward to some of the engagements and questions that perhaps the audience will have regarding this development that you have been using. As I mentioned a little bit earlier, we have a program. In our program, the next presenter is scheduled to be Mr. Binda Zwane. Currently, it seems he's having some technical glitch in terms of logging in. So we are going to adjust the program slightly. Instead of Mr. Zwane, we will have Mr. Hendrik Jenner from Residue Tech, who will then come in, and then we will have his presentation in Hendrik's place a little bit later on. So we'll do a direct swap then, and hopefully the technical issue will be resolved. All right, so I will move on and then do the introduction of Hendrik. And he is going to be presenting to us about digitalizing regeneration operations. So he says about himself, he's a father of 2 dynamic girls and an avid nature and wildlife photographer. He drives a beat-up car, but his camera has a good quality glass. He has 15-year background in data warehousing, architecture, and integration for large corporates. Currently, he's the head of digital development and market lead for Africa, Scandinavia, and Oceania for Residue Tech. Hendrik, we're looking forward to your presentation. Over to you.
Thank you, Muedanyi. Let me just share. So can you all hear me? Hopefully.
Yes, you're audible.
Great. So I don't know what it's like for you, but when I go to a restaurant and agonize over what I'll be eating, and it turns out that my companion has a much better portion or meal in front of them, I do get some kind of sort of portion envy. And I think, to be honest, I think with regards to this seminar, I've had a bit of the equivalent to portion envy in terms of the topic. So digitalization isn't always as fun as talking about sort of big machines and hydraulics and biology and all of those things. But I think it's important to discuss this aspect as well. It's something that's coming, and it's something that where we can find a lot of sort of low-hanging fruit. And I think if we also discuss the possibility of customizing the approach to the area and recognizing the limits, we'll be doing something quite feasible. And the reason the subtitle is termed a lean approach is because our approach is to collect the data and let's say digitize in conjunction with the silvicultural process itself. So that's the reasoning there. Just a quick note about our company. I wouldn't want to assume that everybody knows Residue Tech and what Residue Tech does. We're a Finnish silviculture machinery designer and manufacturer. We have 3 sites in Finland. I'm sitting here in Helsinki, which is the capital, and then we have a dynamic team of software developers in Salo, which is a place where Nokia had one of their sites earlier, so a lot of talent there that we've been able to tap into. And our factory is in a place called Nakkila, and so that's where we're from, and we're neighboring with Sweden. So I know there's a Swedish presenter coming, so we're right next door. We have customers and partners all over the globe. And so the requirement for our solutions is that they should function everywhere. And functioning everywhere doesn't mean that we always have the same product or solution for each and every location. We do a lot of tailoring and customizing and such, depending on the conditions. But when it comes to digital development, what we're trying to do is to have a system and really pool our development so that we can scale up and use the system all over. And that's quite important for us to make sure that we move forward in a constructive way. Our solutions encompass obviously planting machines. We also have a segment where I struggled a little bit to characterize it. It would be sort of stand tending or young stand tending, pre-commercial thinning, coppice management if we're talking about the mechanical type, bioenergy harvesting and cut to tree thinning to a certain diameter. And so that's us in a nutshell. Moving on, let's see if this works. So I'm just going to skip ahead. Obviously, we have to have a reason and hopefully a business reason that makes sense of why we will want to digitalize. We don't want to do it because it's fun or we want to lead the pack or something like that. Of course, that can be a reason, but we need to reflect on what the problems are that we're having, and where having a better view of what's going on in field helps us. So I've listed a few reasons here. You'll probably have others, but this is sort of to sort of ground the presentation in terms of why we want to digitize it. There can be many different reasons to do this. Just see. Okay, and to dig in here a bit, one of the reasons why we would want to digitize is to basically have better planning. Poor planning leads to a lot of waste, as you'll know. And so what we have seen is there are real issues with insufficient monitoring. We just don't know what's going on. We don't have transparency. Even when we do have transparency, it costs a lot. And when we do get it, we don't trust it. So what can you do? Well, you can create monitoring systems. You can start reporting on relevant KPIs, and you can at least strive to document everything at the very finest level of grain possible. So individual tree and individual treatments and silvicultural processes. Another problem is improper site selection, poorly designed sort of planting patterns, and other things can lead to really inefficient resource use. And here is where sort of the accuracy of GPS, GNSS, RTK systems come in, because if you're planning something but you're failing to take into consideration things like leveraging site characteristics and things like that, you'll not be able to efficiently utilize the land. And this is sort of another example of where, let's say, you make mistakes and you don't you're not able to, or you're not aware in field of where these sites are, and there are real risks with treading over areas where you shouldn't be. So being able to disseminate geo data to your operators is really important, and that is sort of where we are headed now. I'm not going to share any customer information in this presentation. This is sort of a tongue-in-cheek example of how you would, again, gather one of these low-hanging fruits in terms of planning your sites. So what we usually see, or what we can see, is you have a site that needs to be planted. The compartment outlines are based on harvesting data. Then you start planning based on that information. You set a target density. This is a Nordic example, so the density stems per hectare is quite high. And then you do your order, you put in your order at the nursery, and you get a certain amount of plants to the site. They may have treatments applied. It's very expensive. And then when the operator opens the work order, they see, okay, there should be some environmental concerns, but we're not quite sure what they are. They're not marked on the map. So just a bit of a tongue-in-cheek comment there. Just don't screw up our certification. Don't do anything that could harm that. And so this is the plan, and then what the completed work order would look like, could look like something like this, where you basically have an area that's been planted. It's nowhere near what the plan is, and you get significant amounts of seedling waste. Even if, let's say, you're able to move seedlings between compartments, it's not like seedling logistics is inexpensive, right? So there's a lot of waste here, and here we come again to that concept of a lean approach. So instead of doing it this way, you need to take care in planning, and you need to move those plans to the operator. Another thing we see a lot of is let's say the seedlings are just not up to par, and when you're going and doing mechanized planting, that will eat into your productivity for sure. And the operator here has commented on the work order that, yes, I found an old burial site, it wasn't marked. This happens to border on a conservation site, so I had to leave a considerable amount of a buffer. It wasn't marked on the map, and then unfortunately I ran over someone's fiber. They noticed it. I apologized. It didn't help. It wasn't marked. So a bit of a tongue-in-cheek example, but this is just to illustrate how broadly the plan can sort of differ from what the actual result is. Another reason we might want to digitize a broad factory is operational. So we want to use digital tools to improve efficiency in our staff. I'm going to move a bit faster now. We don't really have structured communication, so we might want to use digital tools to structure that. Remove, let's say, any misunderstanding related to not having the right facts. And then when we do provide feedback, it's professional and it's based on these facts. And then also to see, okay, this operator works quite well. Can he or she maybe train this other operator who is struggling at this specific thing? And then another one is, okay, so can we use digital tools to introduce new technologies to help prioritize resources and to automate processes? And here's an example of how we or how we've set it up. So use a service, plan well ahead. If you're a contractor, it would be a real boon for you if you could always plan the season or plan the season with the buyer or the forest company well ahead of time. So the way we think about this is provide a portal or a web service to input work order details, geographic information, anything that would be relevant to the contracting party who is carrying out the work. And then once this is ready and it's been accepted by the contractor, the data is moved to the in-field operation, the tablet in the cabin of the excavator in this mechanized example. So instead of the operator having to input a lot of data themselves, they can merely select the work order and start working. And then while this is happening, if you're connected to the internet or your unit is connected to the internet, you will be able to monitor in, let's say, real time or real time in terms of monitoring actions, the results. And of course, the benefit here is to be able to integrate to other systems as well, using sort of integration points, APIs. You can even download to analyze in Excel or Power BI, which is quite prolific nowadays. Let's move on. Another reason you might want to digitize your operations are silvicultural, biological. So if you document at the finest level of grain, you won't have issues sort of identifying where things or where problems have arisen. So you will have the data to perform corrective actions. Another reason is to try to move away from monocultures, maybe not possible in all cases. But let's say up here in Europe, we do have really big issues with bark beetles and pests and things like that. So there is a trend whereby we want to move away from just one monoculture, one tree species per compartment to more mixed stands. And digital tools can aid in planning and executing on this. And then, of course, we have this whole topic of natives versus the sort of standard forestry setup where you want to plant native species and for biodiversity purposes. You can use digital tools to also sort of implement this kind of activity, obviously. And here is a sort of more of a question and look into the future. So heterogeneity can mean a lot of things, but let's say, how would we implement this in a sort of commercial setting? Is it possible, or is it merely for other means? And what would that sort of process look like? Let's say if we could have really accurate maps on where you need to put a specified tree. And then also, of course, documenting what kind of silvicultural inputs you've been using. Can we leverage green means, fertilizers, and so on, and what does that look like? And it's like the big picture, right? So in terms of low-hanging fruit, it's not just the mechanical planting, it's also other silvicultural processes that we can digitize that help trees to grow, like stand tending. We could digitize that as well, and we could leverage inputs from prior stages in the process to aid in, let's say, not hitting target crops when you go into to do the stand tending and so on. So there are lots of opportunities here in this space, not just mechanized planting. And so, just as a final slide, I wanted to highlight what our offering really consists of. So we have a standalone precision forestry offering, which means it's not tied to any one of our, let's say, planting machines or bioenergy harvesters or equipment. Basically, you can, if it makes sense, you can implement it on other tools as well. So we don't restrict that in any way. The way you use it is you use it in conjunction with a web service. So that is a service that is online and where you input data in a structured way. It has a Microsoft Azure backend, so all of the ANSI IT folks at your big corporation can breathe a sigh of relief. It's secure, and that integrates then with the in-field kit, where you have an Android app, a tablet or a phone. You have a control unit, basically a computer that you can have in your excavator, tractor, or other sort of base machine that you're using. And that comes in two flavors, basically. So we have GPS/GNSS level accuracy. And for correction, we also have a base station. So the reason there are two control units on this slide is because one is the base and the other is the rover. They're basically kind of the same. They're just configured differently. So you have the option of starting with a lower level of accuracy and then deciding whether or not you need centimeter level accuracy in the future. Okay, let's see. Thank you. That's my presentation.
Thank you so much, Mr. Jenner. We appreciate that presentation on the digitization. How can we monitor and use the data effectively to improve efficiencies within our forest operations? Thank you for that presentation. And now we are going to proceed and then go through our Q&A question session, where I can see a number of questions that have been posed to the presenters, and I'll go through them and I'll pose them to each presenter and give them an opportunity to respond. We have a bit of time for this, as we are right on time, 11:30 with about 15 minutes. Then we will take a break session after this. So first question goes to Zimbini. You touched on operations that should be prioritized when implementing modernization based on your survey, with harvest waste management as one to reduce burning. Is there any method so far, or modernized method, that can be used?
Thanks for the question, Ayanda. And yes, there are quite a few methods. The problem is context specific, especially with the terrain variations. So with the people that we're working with, so the foresters and NCT, one of the biggest challenges were in relation to the very steep slopes. And the burning works, but then the damage to the soil quality is a concern. Also just taking into account how long they've been using the areas for planting. And what they have explored so far is using, well, broadcasting the waste, but at the same time, they also started exploring using a small-sized agricultural chipper. I don't want to take time to show it, but it's like a small chipper where they can chip the waste and distribute it or broadcast it on the terrain, and merely just to create access, not to get rid of everything. Because as mentioned, the concern is, the risk for fires. And I also just want to touch on what Ruben mentioned with regards to the impact of the operations on, on other silviculture activities or methods. And one of the things that came up is with the broadcasting, it affects the planting a lot more in terms of productivity and efficiency, both planting and pitting, because now, if it is broadcasted, the accessibility is a bit more difficult. So there's a higher risk of tripping and falling, but seeing the soil and identifying the actual pitting spot makes it a bit more challenging, which means that it takes a lot more time for them to get through pitting. Whereas when it is where they chipped, so the accessibility is better, and at the same time they are still reducing the waste load on the ground. There are mulchers and there are the other high technologies, but the biggest concern are the terrain limitations. So the modernization, and especially so far with the work that we've done, is there is a need to mix methods and to explore, in a certain compartment where the terrain is too steep, on the edges where you have the biggest sized waste, that can be chipped because the chipper and tractor can access it. But then further down, you can still distribute or broadcast your waste. And then there are areas that are closer to communities where they can then decide to burn them. But I do think that the shift should be, again, take into account the modern context that we're in and the communities that we work around, and then work with what is going to be appropriate for the context, rather than, I like what Hendrik said earlier on, the one size fits all approach definitely doesn't work well for our context.
Thanks, Simbile, for that response. And here's a question now for Henny, which I expected was going to come. So Henny, here is your big question. Why would the mulching result in such high mortality?
Yeah, no, thanks for that question. So what we noticed when we went for the seedling assessment in the field, we found that a row of seedlings, let's take in a plot, a row of seedlings, 5 to 6 of them died. So and the mulcher was used in other sites. So, and they didn't realize so much mortality in those sites. So our thought now finally came to, maybe it's the site that's the problem. The site was a problem when the machine now was used on that site, and now the open access of the mulcher, as it has chucked away all the residues that are there, and then the issue of now pests coming into now eat up the seedlings that are there. So it resulted in the mortality of now the seedlings in the mulching area when compared to now the semi-mechanized and the manual.
All right, so the other question that links up is, my concern is the impact on other silviculture operations for these different methods. I suppose these are mulching methods. This is from Ruben. When we assess any forestry operations, we should always consider the impact on all aspects, such as fire risk, weeding pests in mulching, also what happens in slope. As forestry often takes place in mountainous areas, does the impact of burning persist over the full rotation, or does it even catch up after the first year? Is burning not less expensive and more productive? It's a mouthful of questions here. What would be your recommended method? Why is manual work quality the worst?
Okay, firstly, I would like to mention that this is a baseline study, and we looked at alternatives to fire. So we didn't focus on fire as a residue management, but we looked at other alternatives, such as the mulching used in that area. So in terms of slope, machines have limit. So other studies, as I indicated, can take it further and look at now slope as now a factor in the project. Moreover, no, it does not, and fire. When the question of fire, it does not, and yes, it has less. It is less expensive and more productive. However, as I mentioned, we were looking at now the alternatives to fire. Hence, we did not now include the component or the factor of fire in the study. I would recommend the fully mechanized method to now as a residue management method, because the mortality that we realized is not the same mortality that the other person can realize in a different area. And as more they did the same study, I think he didn't get as much mortality as we got in this study. So I think the fully mechanized method is the way to go, even though there's slope limitations and other factors. However, it has been used, and it works quite well. So yeah, what are the other questions that are there that I didn't answer?
Thanks, and maybe perhaps let's also look at to Mbekiseni. Are you able to integrate the boom sprayer computer with the plantation map?
Unfortunately, no. So far, we haven't been able to do that, but we did try, and then the machine went up with some high pressure and lots of water that we were putting down. So we stopped, but we're still going to try again.
Okay, and then maybe just to follow up on that, does different slope affect the effectiveness of the machine spraying quality?
We haven't used it where it's really steep. Like I mentioned, our area is quite flat, so we're able to maintain, let's say, the exact same self-leveling kind of distance from the ground for the boom. But I would think if you go into steeper slopes, the machine should then be maybe slightly slower, and maybe it could be affected, but we haven't tried it.
Okay, whilst we are still with you, perhaps let's also do the other two related to the spraying. Does herbicide application, do you mix during herbicide application, do you mix herbicides targeting the grass as well as the woody plant or shrubs? This is from Jimmy Jamali.
No, we go in for the grasses because the grasses grow first here in Zululand. So we go in for the grasses, and then 2 weeks later we go for the broadleaf. We don't have any combination or any cocktail that we can make unless we do the full cover spray with glyphosate.
Okay. Thanks for that. And then lastly, from Zwandile Chekula, he says, Mr. Zele, how does your operator see if there's a blocked nozzle or which nozzle is not putting out the same amount of water with others?
You would have an error message on the screen. It does show, so you will see it on his screen.
Okay, back to Henny. This is from Ulrich Hector. He says, what was the main cause of the high mortality in the mechanized residue method? You touched on this earlier. If you looked at the impact of frost on mortality in residue retention practices, and he says in parentheses, residue retention can cause frost pockets around seedlings and cause mortality. So he inquires, but also gives a possibility or probability to the cause.
Okay, yeah, we did not look at now the frost as a measure of, or as a effect or a factor to mortality. However, I think future studies can now incorporate that and look at how would frost then result in mortality in the seedlings.
Yes, and perhaps just to add, this was just a single area, and one would want to do multiple studies so that you can have more generalized feedback. What is of interest is when the research study was presented back to MTO, they indicated that they had not picked up any significant mortality in the mulched areas since they had been using the mulcher in different areas. So it is important that we do multiple studies so that we can ensure that the information can be generalized. I know Zimbili wanted to add something as well. Please go ahead. And if there are any other questions, please feel free to post them or follow-ups on the chat.
Yes, I think it ties to Ruben's questions, but also the other ones, and maybe a thought for us to explore further on is that now we are advancing a lot towards knowing how to use big data to make better decisions. And I think what we need to do as an industry, at least explore, is to go back to the data that we've accumulated over the years and then reassess them with the understanding of our different conditions and terrains, but at the same time to relook at where we were and the data that was collected, how does it play out now, take into account what we know now. And I think that will also help us understand that even though we have all these different options, we are moving to a time where we need to start implementing multiple approaches to optimize our operations, but at the same time, to get the best out of the different tools we have, with the interest of understanding that we want to have a lower environmental impact. And I think with the thought of how that even affects other operations or methods in silviculture, is that we then, if we analyze what's been there, we are able to also track what the impact has been better. I know that data is intellectual property that is kept very close, but I do think that there is an opportunity for us to utilize this new, I don't know, like the big data management approach to make better decisions will really help us actually move a bit more forward. And for us to ensure that we keep doing new studies rather than repeating other studies in specific areas, because we do know a lot of things, but then they're also not all easily accessible due to, some content is kept internal. But raw data can help us all to understand our context better, but also make better decisions in the investment and improving the efficiencies.
Thanks. Perhaps, Henrik, on my side, just a question to you. Do you find, and of course we have this digitization that can take place, but what is the impact of connectivity challenges in terms of the reliability of data and accuracy?
That's a really, really good question, and it's a multifaceted one. I'll try to keep my answer quite compact. So when you have a system that relies on let's say, web-based technologies and online use, that's one dimension. But then obviously you won't have internet connectivity all the time in the forests, unless Elon Musk has taken a real interest in your country and is spreading his technology everywhere. But unfortunately, we can't rely on that everywhere. So when we move data from a plant scenario in the office, we need to be able that we can move it to the tablets in the field, right? And so that the data can then be stored offline. That's one dimension. Another dimension when it comes to, let's say, accuracy, and if we're talking about accuracy in terms of how accurately are you planting, for instance. The real challenge there is to find a technology that can work basically all over the globe, if that's what you want. And because we have customers sort of everywhere, we can't rely on localized RTK services, for instance. We can't even rely on third-party correction services. We've played that game, we've lost a bit, and we don't want to go there again. So our solution is more in terms of using basically local radio to be able to correct the GPS signal in those scenarios where you need centimeter level accuracy. So I hope that kind of helps and clarifies things.
Okay. Yes, it does. Then I'm going to take the two more questions that I hear. We have one from Siatola Tony, and the question is, I like the innovative idea on the whole that was altered to a more sharper blade and is something that one can consider, but my concern is the quality of the pit in terms of the depth. Any possible innovative means to deal with the depth of the pit, Zimbili?
Yes, so that was us just testing it from more an ergonomic perspective. I thank you for your questions, Yakola. I think the reason why we cut it that way is because in the field, what they usually do is they use the pickaxe and the mattock. The mattock is the one that has like the sharp pitting head and then a bit of a wider blade on the side. But then the mattock is like the pitting part of the mattock is a bit shorter. Whereas with the pickaxe, the blade is a bit long enough. So what we also thought about, which we haven't enacted, is to actually see how the actual the pickaxe can also be amended to make it a bit wider. Yes, but also being able to have that option of making it a bit longer to increase the pit depth and quality. However, we haven't explored that option yet. But I think for me, this is an opportunity for us to not forget that even though we've had pickaxes for as long as probably longer than I was born, but as we are modernizing and improving our operations, we tend to focus on the more mechanical parts, like, the new technology. But what about improving what we already have to make it more appropriate for our conditions? And that goes with the pickaxe can be amended multiple times to meet our needs. And one tool that I saw, I think it was, yes, when I was doing my field work, it's a manual auger. It's like a triangulated, inverted A auger, that's what they call it. And it's a manual one where you twist and then it makes the hole. It has the dimensions that you need for the size that you need. But at the same time, the workload is no more on you having to lift, for example. So you just merely have to apply your body's weight and then make that hole by twisting, which is a really good example of what it means to develop technology within our modern times, but still staying basic with it, taking into account our context. So I think we also need to utilize a lot more of our explorative approaches and still consider that modernization, because I think the misconception there is that modernization is mechanization. And I think we need to specify that it's not. It is just as we evolve in our modern context, what is there now? What can we add to what we already have to improve things? And mechanization is part of that. But yeah, I hope that answers your question.
Okay, no, I think that's a comprehensive enough response. So we are going to end it off here. There are a couple of questions that have come through, and I would just encourage the presenters to perhaps just reply to them down there under our chat. There is a reply button at the bottom that you can reply to, and then we'll take a brief break, and then we will commence at 12 when we will start off looking at the plantation forestry nursery, automation, as well as robotics. Interesting presentation coming up after the break. And I would like to thank our first session presenters, from Zimbili, Henny, as well as Mr. Nsele and Mr. Jenna, for your time and for presenting so comprehensively and sticking within the time. I appreciate that. And we are now able to take a break, and then we'll come back at 12. Thank you. Come back to everyone. We are now going to commence with the second session. And our second session, as indicated earlier, has got a bit of a slight change. So we are going to have the presentation on plantation forestry, nursery automation and robotics. That will then be followed by the presentation on mechanized planting in Swaziland. And that comes in place of the digitalizing regeneration operations, which we had earlier due to technical issues with Mr. Zwane's connection. So he will then present at 12:25. Then that will be followed by Mr. Krista Larsen, who will give the presentation on mechanized planting on diverse conditions with the plant mix. Then lastly, we will have latest updates and initiatives of mechanized planting in Brazil. That will be from Mr. Cassio Gomez. Okay, so without wasting any further time, I would like to introduce Mr. Joop Hendricks. He holds a BSc in Agriculture Engineering from the Tropical Agriculture College, Denver, majoring in international agri-food production and marketing and a higher vocational education. He's a man with a lot of experience and a comprehensive experience here. His career started as an area manager at the KLM Cargo in the US, and then promoted to the country manager based in Quito, Ecuador. And he then worked for Reed Elsevier in North America as the area manager based in Chicago. He then worked for Landguard in Germany as the interim manager, and then worked for, it's complicated names here, Joop, Fides as a production manager for many years. And just to mention a few, but he's also the owner of Geiger Ventures. Currently, he holds a position as the Global Business Development Manager at ISO Group, being responsible for identifying emerging business areas and defining the entry strategy. He's a passionate traveler for work and leisure, and while abroad, he has made a hobby of doing some scuba diving and skiing, and when at home, he loves his garden. Joop, thank you so much. I know you are not very well, but thank you for persevering through your cold and still being able to present. Over to you.
Thank you, Muedanyi. It was quite an extensive introduction. Maybe too much detail in there, but for starters, thank you for having me. And beforehand, my apologies. I'm sitting here with the flu, so maybe not working at 100% brain power and capacity now. So if there's anything unclear, please don't hesitate just to interrupt me. So let's get going then. We are supposed to have a chat now about automation and robotics in specifically nurseries. Let me find out if I can start sharing the screen here. There we go. That seems to work, right, Muedanyi? No?
Yes, all clear.
So, nurseries in particular, and why nurseries? For that, I have to go a few steps back into the history of our company. We've been around for a little over 20 years now, from the beginning on, involved in robotics, planting of cuttings, essentially, planting of young plants, transplanting, grading, sorting, all with the objective to automate manual labor and make the output more efficient in terms of economics, product quality, and consistency. We have quite a substantial installed base around the globe now, yeah, I'm only with the company, by the way, just for 5 months now, and ever since very impressed by the toughness, the quality of the products that ISO makes, because in those 21 years of existence now, still 99.8% of our machines is still in operation. So we've been quite effective, I think, in what we do. And I would like to give an example now of the products, solutions that we make. This was one of the first systems, planting chrysanthemums as young plants into the greenhouse directly. Bulb sorting, we have now 100% market share. Every bulb grower, tulip bulb grower in the Netherlands has one of these machines installed. Chrysanthemums, the same thing. Planting cuttings is one of the key areas of our company. This is where we take DNA, a piece of tissue for DNA analysis. It's a quite an impressive machine for grafting. In this case, we're grafting tomato plants at a capacity of 4,000 plants per hour. Is a rose grafter, just taking bits of plant material, sticking into the soil directly. There's a grading machine, very relevant for young eucalyptus plants after the first rooting stage. So how did a horticultural company mainly active now in cut flowers and ornamentals and high wire crops, mostly grown in greenhouses, get involved in the forestry? That is with a very specific scope, and in particular on planting cuttings, young trees, and in a later growing stage, the grading and sorting. So it only of the whole portfolio that we do, 2 key areas of interest. And in a bit more detail, planting cuttings. There's a particular robot. I will show you a brief movie about that next. It had been specifically developed for in horticulture, and now with modifications, we have demonstrated to be very effective in eucalyptus. The film is still with horticultural plants, not with forestry, but it gives a good demonstration of the functionality and the speed. This particular company is, the video we look at now, is a breeding and propagation company of chrysanthemums. These cuttings are grown currently mainly in East Africa, then shipped to the Netherlands and planted in little peat blocks. And robots that we see here are taking care of that process. This company is planting nearly 1 billion cuttings per year using our machines. On that blue belt that we see here, you see 4 cameras positioned straight above. With these cameras, we identify every single cutting. And there are certain specifications that the grower can supply us with to be able to select the right cutting. So any deviations in terms of, for instance, length or broken leaves or certain any anatomical deformations that the grower wants to avoid sticking, will be given. The system can work with that and discard the non-conforming cuttings. So what is the trick of this system? I said the vision system will avoid. It's the first entry stage actually for a uniform production. And so all the planted cells in the target tray are of uniform anatomical product properties. Then the planting is very important. This robot will plant always centered in a particular block, no matter if it's a paper pot, if it's a peat block, or a standard tray with 2 beds, or whatever the target tray is, the cutting will be planted exactly in the center. The planting depth is also pretty crucial for every crop that we deal with, and we can plant at a predetermined planting depth with an accuracy of 1 millimeter. And then a very unique and distinctive and also patented function of our robot is that we will actually pull in the cutting. We have very delicate crops that we work with, where if you would push in the stem, it will bend or disform. We have a technology where the gripper actually pulls the cutting into the ground from the lowest part of the stem, and then slightly applies a bit of pressure to close any gaps between substrate and stem. So much for planting cuttings. I'd like to show you now a proposition that we are developing for the grading and sorting stages. So imagine after the first rooting stage of your plants, you might want to do this first selection, and later on in the growing stages, of course, a second and a third selection. This robot will again select and sort on predetermined settings specified by the grower. Apologies, the text is in Dutch apparently. Essentially, a robot gripper takes out the plant from a cell. In this case, we would take out, for instance, the bed. This is a slow motion picture, of course, where 16 images are made from every individual plant. And then, of course, the vision system will generate a 3D model of the individual plant and identify conformity of the plant to these to the different classifications. Say we want to have 3 different classifications, A, B, C quality. Then that will be the result in the target trace. What we see here is also a bit of spacing, so we replant in a checkerboard pattern rather than cell by cell. Very simple to operate. You don't really need, of course, highly educated workers to operate the machine. Of course, some sensibility, feeling with technology is needed, but in general, everyone, even I, could operate a machine like this. So, why is grading and sorting? The objective for us and our clients that we are developing this with now is uniformity. You want to maximize the capacity of your nursery, reduce as much input as possible. So you want to fill up the capacity to 100%, so you're not wasting labor, energy, water on plants that will never make it eventually. And most important, of course, at the end, the overall product quality will likely increase. Of course, you need the grower for that. We only support the grower in that sense. And that should give you a good idea on the capacities and the machines that we have. So if we are to start with this, and we are, as a matter of fact, in Brazil, on a very short term, then there are some requirements based on our experience with other crops. We need some help from and sensibility from our clients, because sometimes the workflow and the existing process in a nursery can or needs to be tweaked in order to enable full effectiveness of that robot, or any automation solution, as a matter of fact. A robot will never be 100% effective in no single case. And why is that? Because, especially in our case, we work with a natural product, and there will be surprises on how Mother Nature can shape a cutting or can shape a plant, challenging the vision system and hence the effectiveness. There will be human errors around the robot, essentially. There will be inhibiting factors like power outages. So never expect that if you throw in a robot in the current process, then that is the end of the story. It's the beginning of a new journey leading to higher efficiency and eventually higher profitability of this company. And to close off with that profitability, the economics that we see are very sound. We have payback times of the investment in at least less than 4 years, and for some products even, or cases I should say, months only, and significant returns on investment over the 10-year lifespan of the products that we calculate with. So this is a high-level brief overview. Understand this is just the tip of the topic, so to say, and I'm glad to answer any questions or in separate direct contact, go into more detail on your questions in case. My contact is here below, and Muedanyi also has my details, so feel free to reach out.
Thanks so much, Job. Very, very interesting things that the robots can do in terms of the sorting, grading, as well as producing cuttings. And it will be interesting to see how that is integrated to more forestry specific cutting applications in, let's say, eucalyptus and various types of clones. So thank you for that a very interesting presentation. So we are going to now move on to the next presentation, but just an encouragement to all our attendees that we still have the Q&A session, which will take place at the end. So please pose your questions under the Q&A part so that we can be able to pose them to the presenter for you to get clarity in case you need. So our next presentation is going to be focused on mechanized planting in Swaziland. And the presentation will be delivered by Mr. Muedanyi. He holds a diploma and BTech in forestry from the Technikon of Port Elizabeth, now known as the Nelson Mandela University. He also holds a master's in business administration from the Millpark Business School. His career started out as a forester working for Usutu Pulp Company, 1996 to 2003. He was then promoted to become the forestry business manager between 2003 and 2007. He then moved to Peak Timbers to become the strategic planning manager all the way to 2014. And he currently is a managing director and senior consultant in Connections Investment Pty, based in Swaziland. He's been involved in various other trainings as well as leadership roles, one of which is that he was the secretary of Pigs Peak Club from 2010 to 2013, and is a member of the drafting committee of the drafting of the Forestry Bill of Swaziland in 2010. Mr. Zwane, we are looking forward to your presentation, and if you could share your screen. Okay, yes, that's visible. And if you just slightly adjust your camera so that you are visible. Thanks. Over to you.
Okay, everyone, Thanks for the opportunity. I'll be sharing the early lessons on the mechanized planting in Swaziland. We just purchased a machine from Wooltech in Finland to assist us in our plant. I'm Muedanyi. I'm the Managing Director of Connections Investments, which was established in 2014. We have a staff of about 145 people doing culture work at Montigny and at TWK in Pittsburgh, Swaziland. The objective of the presentation is to share our experiences on the introduction of mechanized planting in Swaziland, which is believed to be the first in Africa. The reasons to mechanize. We had associated problems which came from shortage of labor. I think we've been operating for 10 years, but people, about 2,000 people have left our employ in the forest sector. Due to that, they don't like the work. Poor survival and quality issues. Extreme weather conditions. These days, we receive terrible weather for a person working in the sun for the whole day. And compliance issues, I think that the welfare of the people becomes critical. So the cost is escalating while the minimum wage is increasing and the output and the quality is never adjusted accordingly, which makes it usually people in future might be more expensive than the machinery. All these shortages have been caused by the increase in literacy of the people, poor health condition of the people due to HIV and AIDS, and also increased alternative employment, which is security guards. There are more shops now and textile factories. There's so much illegal farming taking place, street vending, and night work in sawmills. And also the number of employers, as we on outsourcing, there are a lot of number of employers in the industry. So trying to speak to someone in the workplace doesn't help, because within 24 hours, it's got a new job somewhere else. The benefits we'll see when we mechanize is future cost savings once the system becomes efficient, reduced accidents, minimal human error in the planting like clay rooting, shallow pitting, air pockets, and theft of resources. And we have to invest less on idle assets, like building big villages, purchasing labor trucks, which now each labor truck is about $1 million, high cost for equipment compensation, provision for sick leave and medicals, and protective clothing, as well as attending to industrial relations in courts. In 2022, November, this equipment was delivered from Finland. It came to Swaziland. It's the planting machine ASP360. The equipment consists of this compressor. The equipment is an excavator 210 SKP, which has been modified for the planting operation by fitting a couple of components, which is the compressor, which is used to suck the seedlings for planting. Also, it's got a gel tank, which is for applying the gel. Also pesticide, and also got a tank. We remove the waste of the tank and put in of the excavator and put in a tank, which is about 3,500 liters to feed water into the planting system. The water from there is taken by a pump, which pumps every 2 seconds. It sends water to the planting head. There's a fertilizer tray and the empty seedlings and the pitching tool, as well as the seedlings which are planted from the head. The machine functions. The machine is supposed to be doing nothing. Unfortunately, at this moment, the machine system is not operational. Just receive a new one from the process. The machine removes mesh before the planting. There's the ability to pitch the pitch is about 45 meters deep. And
Sorry, Mr. Zwane.
Wide.
I think maybe once you pause the sound, you can stop.
It also has the possibility to apply all of the drivers, also ability to test the test. And that's what for the grids.
Sorry, Mr. Zwane. If you can just perhaps
Okay, team composition. The team composition is based on a target of planting 75 hectares per month. The personnel we're operating on currently is 3 operators who work on a shift system. They work day and night for 12 hours a day. We also have 1 mechanic on site full time. We've got 3 assistants. We are helping in loading the seedlings and also attending to trees that have not been placed properly by the machine, of which I think in future we might face the assistants as the operators get used to the machine. We've got 1 water supply driver to bring water to the field. Other support equipment for the machinery, LPV to supply seedlings and building the excavator, tractor 5,000 liters, and a seedling trailer. Yes, strategic benefits that we've seen with the use of the equipment over the past 8-10 months. We've seen the establishment of areas in remote areas being flattened, whereby you don't have to employ more people to establish an area which is far from the normal blocks. It has helped us a lot, like in the Usutu fitting in block Y. Establishment on areas with high fuel loads. We've been able to extend the planting season, done plantings in June, July with better survival. GPS documentation of seedlings and 2P turnaround time gains, which we gained from plantings in July, which have been good. Also, good survival due to the large pits, which are deep enough, and also the compaction, which is not by hand, which is by the machinery, which drives away all the air pockets. From the look of things, you will think a pit is got closed, whereas on the root plug, they will not close because they were broken during the commission process. We analyzed some of the seedling survival we had. We planted pines at high altitude. We just planted in April, May, June. Unfortunately, we couldn't get proper figures as this year we had frost which was close to snow, and it killed most of the seedlings that we planted late this year. We planted ukes, which is Eucalyptus smithi at high altitude. We planted in January, February, and March. That was our critical training phase. It achieved 90% survival. And as we just troubleshoot what has caused the 90% survival, that maybe the operators were not placing the seedlings well deep enough. They were not sure, they didn't remove the slash properly, which is still part of the training. Then in June, July, we planted GXU at low altitude. And in one stand, we got 78%, and other stand, we got 90% in winter. I think the 90% was quite good. For the 78, we're still investigating of what could be the problems, because the 90 and the 8% are different soil types. So we're still investigating what could cause so much mortality on the other stand. Productivity. Okay. The production of the machine, when we purchased it, was pegged at 360 per hour. Currently, we're making an average of 150 to 175 per hour. We are pushing it to 250 as we get more training and get better seedling quality and also good areas. We'll try and achieve the 250. The productivity is affected mainly by slash condition, of which plant areas are better to plant compared to slash areas. Species being planted on your Pinus eloti, you get more productivity compared to your Pinus patula. But also to add to the harvesting system you use, infield processing, roadside processing, and windrows. All these have got a very, very impact on the productivity of the machinery. Other factors are all stump lines, which affects the movement of the machinery. If the stumps are not straight enough, then find that you have to drive the machine on top of stump, whereby you have to push lower. Stump height. If the stumps are high, also the movement of the machine is being low. Lead distances. We've observed that when the lead is long, the productivity is improved drastically on the machinery, as there are few turning time. Operator experience is quite key. As operators still new on their first year, we still hope that with experience, the whole system will improve. Seedling trait specification. We've tried almost all the traits in the industry, and they are all able to take to the machine to work on the machine now. Forestering worked well, but we have issues with the growing medium. If the growing medium is not good, it doesn't work, as we'll see on the next slide. The unit growth will work fine. The elepods were perfect. They are very, very good for the machine, I think, which the industry are encouraged to use most of the time. They improve our productivity. And also, the Sabi 49s are good trays. With the bigger plug and good development, they do very, very well with the machine. Critical seedling quality factors. I think for the project to be successful, the seedlings must be healthy. To make sure that the only thing that will die is mechanical, not due to disease or ever after planting. The height, at least need a height of about 15 to 20 centimeters, so it doesn't get buried when planting. The seedling structure, the seedling must be straight so that it doesn't hook onto the tubes as it moves to the planting tube. Growing medium is very, very critical, because if the growing medium is not binding well, it loses all the soils in the before it gets into the planting hole. Also, the seedlings you use in the machinery must have a good root plug and good root development. So very, very critical to make sure that it doesn't lose the soil as it moves on the seedling tray. We made an analysis of the different times it takes for the seedling to get to the planting tube. The seedling, see here, straight on the tray. After 30 minutes on the tray before it goes to the planting, this is the situation. Because of the growing medium, it gets loose. It loses the growing medium as it moves on the carousel. After an hour, the seedlings tends to have lost a lot, which is not suitable for planting anymore. So it's very, very critical that the roots must bind properly and the growing medium must be of the right size. That's why I prefer the elepods, because the growing medium there, it's well settled around. Challenges that we've had with the machinery. Okay, the mating system is not in place. We had a couple of teething problems. The breaking bolts, some gel blockages as we're planting, tube availability as we could not hold back the planting waiting for the machinery to be delivered in December, whereas we're already in season already. So some of the areas reserved for the machinery had to be taken. High cost per hectare. Our cost per hectare currently is very high as we are training. I think our productivity is still below the target. We're doing about 40-45 per month as opposed to 75, and the fixed costs are hitting up a lot. And also definitely the powering equipment. So it's new in Africa, new to us. We still have to understand that. But the machine needs constant maintenance, bolt tightening and greasing. And unfortunately, you cannot operate it without a mechanic on site, because there's to attend to the issue almost every shift change. Currently, the euro rate is not favorable for the project, as getting new space from Finland is getting expensive. When we started planning for the project, the exchange rate was about 14, and now the rate is around 15. So all the costings have just changed to a disadvantage. So, opportunities, we've not had serious problems with spare parts since the machine arrived. Some of the components used in the machine are available in South Africa. So we've been able to source some components from South Africa to use the machine. We've been able to also machine some components in Swaziland over the year. Also, shipping from Finland to Swaziland takes only 4 days, and unfortunately comes at a high cost. I think that will help us with the quick turnaround time for any special space needed from Finland. Also, on a positive note, we've been able to maintain the machine for a year now on our own without flying in someone from Finland to attend to a problem. Here, I just want to show you the slash conditions that we use the machine on. We're still on the training phase. It succeeds to get plants in, but the productivity was quite low when working on the stands. We hope with time it will improve. When we purchase the machine, planning to purchase the machine, we listed a couple of possible challenges that the machine, if the machine comes to Africa, this is going to happen. We're worried that during the training phase, the below productivity, which has happened, and we're working on that. We also anticipated of the size of our mountains, that there are mountains, the high stumps, and the rocks in our areas. Well, we've been able to get pleasure compartments whereby we've been able to work without a lot of stumps and rocks in our operation. Smaller compartments. I think where we are working now, the working blocks of 75 hectares being built at a time, and that has helped us to lower the regeneration cost 1 month or 2 in the same vicinity before we tie a low break to move us to the next compartment. A lack of expertise to maintain these machines locally. Well, from being able to maintain the machine for the past year without getting specialists, I think we were trained enough at the delivery. I think that's also been a success. After sales backup, as there's no dealer in Africa, we're still struggling with this one. As any parts we need to get them from Finland on a daily basis. But the dealer is trying to look around of who can they get to partner with in Africa. Short planting window. Normally our planting ended in March, but with the machine I've been able to increase to June, July with a success. Planting at night. We've been able to plant day and night, 24 hours, and the productivity for day and night planting is not that much different. So we're able to fully utilize the machine almost on a daily basis. And that's going to drop down the cost, I think, if we were able to achieve that. Cost-wise, the machine is costing us a lot. We planning to go to average 4,500 per hectare at planting. Currently, we are sitting at about 6,000 to 7,000 due to the low productivity. But with time and with the proper training and also proper planning for equipment, we are planning to drop down the planting rates to about 4,500 per hectare, only excluding the resources, which is your gel and the fertilizers. Thank you.
Thank you, Mr. Zwane, for that comprehensive presentation, details of lessons, challenges, as well as opportunities for improvement. It was a very interesting presentation based on your experience, and I'm sure there will be a lot of engagement and questions from people that want to learn from your experience as well. So we will deal with those during our Q&A session. As we move on, we are now going to, from a tracked machine, we are going to a wheeled, purpose-built machine. And I'm going to now introduce Mr. Christopher Larsson. And just a little bit about him. He got his education from the Forestry College in Sweden. And in terms of work experience, he was born and raised on a farm, primarily focusing on managing its own forests. He's been operating harvesters, forwarders, as well as log trucks, and been involved 24 years of after-sales experience for Caterpillar under various roles such as technical support, warranty administration, service training, manufacturing quality, product problem management, as well as goodwill administration. He has lived in 3 different countries and worked in 45. So his current role, he joined Platma Forestry 2.5 years ago as a product manager, and he assists the Platma team to bring the prototype to production and develop new markets. Mr. Larsson, we're looking forward to your presentation, and thank you very much for taking the time to share your experiences. Over to you.
Thank you, Mr. Muedanyi. I appreciate the opportunity for Platma Forestry to join this event today to speak more about our reforestation machine, PlantMax. And I have a few slides to cover, and then at the end, I also have a 2-minute video that hopefully will play well for everyone to see. Some of the topics in this presentation will cover the company, some different planting methods, and more specifically on our product, the PlantMax, where we will be looking at the ground preparation and planting, as well as flexibility and performance, and of course, some of the advantages with the machine. And in the end, we also have some quotes from some of the professionals around the world that had a chance to look at our machine so far. And the companies and people involved in the development of this product literally have hundreds of years of experience combined, of course, in the development, manufacturing, sales, and service of forestry machinery all over the world. So even if the company is fairly young, it was founded in 2018, the people working in the company have a lot of experience from around the world. The 2 founders, Stig Linderholm and Hans Arvidsson, they have been working together, developing forestry equipment for many, many decades. And throughout the years, their vision has always been to make heavy-duty, reliable, and service-friendly equipment for worldwide use by forestry professionals. And some of the more well-known projects that they've been responsible for are the LogMax harvesting heads, the Ecolog harvesters and forwarders, and also the later versions of the Silvanova planter, which took place in the late 90s. So in 2018, after some discussions with the Swedish State Forest Company and their nursery division, it was obvious to Stig and Hans that the need for an efficient planting machine was now bigger than ever. And since the 90s, when they were participating in this Silvanova project, they had ideas about improvements, and these ideas have been growing both in Hans and Stig, and they felt that now it was time for this to happen again. And I think most of us are very familiar with different innovative projects. Some are actual machines working in the dirt, some are innovations on the drawing board, but as you can see in the center of the picture, and as we also heard in the beginning here, tree planting is still very much a manual process, but the mechanization is under the scope now. That's really why we have this presentation as well. And if we look at our product more specifically, it can do ground preparation and planting at the same time with the same machine. And if we start here in the rear of the machine, we have the 2 planting arms that can operate individually. We have the rear planting cab. This is where you have the second operator primarily responsible for putting seedlings in the cups. And then here in the middle, we have the seedling storage that can hold up to 30,000 seedlings, depending on tray types and size of seedlings. And here in the middle, number 4 is what we call the scarifier. I will talk more about this later on, but this is the product that is responsible for the ground preparation. And then here in the front, we have the carrier. In this case, the installation is done on an Ecolog forwarder. Everyone involved in tree planting knows that it has to be a flexible piece of machinery to be successful in planting in different conditions. We heard several of the presenters talking about many of the challenges, and with this machine being invented and developed in Sweden, I can guarantee you that it's been climbing more rocks and stumps than almost anyone can imagine. So it had a great ground to be developed in, and we feel it's ready for pretty much any condition we have seen. We had focused to make the machine versatile and adaptable to different ground conditions and also different seedling conditions, simply because that is the variation you have. We wanted our machine to be capable of planting in more varying ground conditions and also with all these different seedlings that we have heard people talk about so far. And this particular picture here shows the row spacing. We can use GPS for spacing the passes out. We can go infinity on the seedling spacing in the row, and we can alter the width between the planting arms as well, that I will show a little bit more on later. And continue on the subject of flexibility. We have a variety of settings that we can alter to accommodate different ground and different seedling conditions. And what we have done is that we have grouped these settings into categories that makes it very easy for the operator to only have a few selections to choose from, and then the machine will take care of the actions behind the scenes. And selecting the most appropriate type of seedling and ground condition, the PlantNext will relay these settings to the scarifier, because there is communication between the scarifier and the planting arms, and they will actually, I'm going to minimize that window here. We can move on to the next slide, and I will show you on the fly, we can change planting position between planting in the ditch or planting in the mound. And some of you may be familiar with why you have to have this choice in certain conditions. And if it's wet, you want the seedling to be planted a bit higher. And if it's dry and not so much material, then you're planting in what we call the ditch, the low area here. And these are easy to toggle in the front cab, so the operator can switch between these on the go without stopping the machine. This slide shows the PlantNext wide option. The first machine, the prototype, was planting narrower because those are the dimensions we are using typically in Sweden. So we have one configuration that can plant from 2 to 3.2 meter, and then we have the wide configuration that can plant from 3.1 to 3.84. So we have both mechanical adjustments sideways on the planting arms, as well as hydraulic plus and minus 10 degrees. And this is helping us to meet the requirements from different forest companies, because if there's one thing you can be sure of, it is that it will never be the same from one place to the other. If we look at some of the performance details, this machine has some incredible performance built into it, and in good conditions, the machine has a technical capacity to plant 3,000 seedlings per hour in continuous planting. That is, of course, not the same as you would do 24,000 seedlings in an 8-hour day. You have turnaround time, you have logistics around the machine, other things that is outside of our control, but at least it shows you what the capability is of the machine. And as I mentioned before, the seedling storage can hold up to 30,000 seedlings, depending on the size. And the size can vary quite a lot, as we know. We have also focused on making sure that you can run the machine as many hours as possible without stopping the machine. So we do have fuel and seedling storage big enough to run a full shift without any problem. And as I mentioned before, we run 2 operators on this machine, and refueling and changing of seedling storage can be done at shift change. And what you see here is actually a night operation in Canada a couple of years ago. Nice seedlings there. So looking at some of the advantages with our machine, we have numerous advantages with this machine. We are able to add fertilizer. We can do continuous, we can do intermittent fertilization. We have herbicide spray nozzles on the planting arms that can be adjusted so they cover different size of circular area around the seedlings as it's being sprayed. So, and there's also a lot of data collection. So the opportunities is almost endless. And the main thing is that you do ground preparation and planting with one machine in the same pass. And when we mention here that normally you don't have to wait for ground settling, in the Scandinavian area, typically they do scarification and then they have to wait for the winter thaw to prepare the soil and compact the soil. But now we can do that with the rear bogie because the scarifier is mounted in the middle of the machine. So we're saving some time there for the seedlings. Every planting is done the same way according to the settings that you have chosen. So you have different force, ground force and compaction force that you can choose, and it will repeat this over and over until you find it necessary to change it again. And as I mentioned before, we have this fertilizer and additives that you can add to the machine as well, and it will increase the value of the machine. Looking at the data collection, we have planting spots, date and time, who were the operators, pre-species, etc., etc. We are collecting a lot of data around the planting activity because, as we heard in one of the earlier presentations, it is important with the data to know what the machine has been doing, where something may have to be made different, etc. And we are using real time, so we have a web-based platform that you can go log into and see where is the machine, how fast is it driving, how many seedlings are being planted, etc., etc. And here are some examples of the map data that we are collecting. So you can see which arm has been planting where. So for example, over here, you see orange and green, that's left and right planting arm. Each of the dots is a seedling. And if you magnify this area, we have different colors. The red means the arms were hitting a rock, so it couldn't successfully plant the seedling. And it points there's a triangle pointing towards the direction of travel. So we get a map showing if you had rocky areas, if you had wet areas, etc. So that is all useful data for the landowner. We installed the planting unit and the scarifier on a forwarder. Therefore, it is possible to remove these 2 tools, and after a few days of work, you can convert the machine into something else, like firefighting or spraying, if your planting season is short. This is our scarifier. The product name is MediFlex. It allows you to have a very versatile ground preparation. It has position sensors, it can control pressures up and down, and you can toggle very easily between intermittent scarification, continuous mound, continuous ditch, and you can quickly change pressures, and there is a protection system, so if the arms are getting stuck in rocks and stumps, it will lift the arms automatically and then come back down again when the conditions are favorable again. We also run a ripper project. As you can see in the picture here, It's been going on in Brazil for some time, and we have learned a lot about that. And we are now working on upgrades that we are going to present later here. And just during the Expo Forestry show recently in Brazil in beginning of August, we were able to demonstrate intermittent fertilization as well, which is a big saving since the cost of fertilizer has become quite high nowadays. The seedling conveyor is very flexible and has been designed to carry many kinds of different seedlings. We have successfully planted seedlings where the green portion is as short as 4 centimeters, and we can also plant all the way up to 60, 70 centimeter tall seedlings. Primarily, we focus on containerized seedlings. We can hold up to 60 millimeter in diameter, and we use different air nozzles to facilitate seedling transport down to the tip of the arm if necessary. And here we have some quotes. This is from one demo that we did in Alabama, USA. And as you can see from Robert Milstead, the forester at Hancock, he was very impressed of the slope capability. We were planting 35%, which is the same as 20 degrees slopes with ease, both up and downhill, of course. And we were able to clear the undergrowth. You can see in the picture here that we have quite a lot of undergrowth on this site, and the scarifier is clearing that nicely and planting behind. This is a machine in Sweden, operating at Holmen Skog, one of the bigger Swedish forest companies. And their biggest takeaway, other than, of course, being productive without having to have a lot of people on site, is the fact that they are scarifying and planting at the same time, so they're gaining a year on the growth side. We've done demos in Canada with our prototype in some challenging conditions, and what they were mostly impressed of is the fact that the machine was doing everything we said it could do, and actually a bit more. And believe me, they were putting us in some very challenging conditions, but the machine did very well. And we have an ongoing roadshow in Brazil. We have a dealer for South America, which is Timber, headquartered in Curitiba, Brazil. And they are an outstanding partner for us in terms of taking care of local activity. The names of the forest companies on the left side here are all the companies where we have been doing actual demos for since we started in November last year. And on each of those demos, we have let the forest company run the machine with their own people, with their own seedlings, with their own conditions. It's been a learning experience for us and for them as well, but a great experience overall for the people to see the machine firsthand and operating. Those were the slides I had to share, and if you don't mind, I'm gonna go to share this video that is 2 minutes, and after that we can continue. And here you can see how the machine is compacting the mound that is created by the scarifier. This is some early testing in Sweden. This is as good as the ground will ever get in Sweden. I can guarantee you that. You will see later on here some real challenging ground conditions. This is a continuous mound. You can see that the arm is going the same. This is a burnt site in the US. It was just easily raking the surface. Here we use intermittent scarification, so we are just scarifying a short distance, and then this information is relayed back to the planting arms, and it will plant correctly on each of those spots. This is a night operation in Canada. They wanted to see night operation as well as slope capability. The machine has plenty of lights. We even have a machine in Sweden operating with cameras to detect ground conditions, to identify better areas to plant. Here you can see some of the slope capabilities. This is from Alabama, USA. Here's another slope. It's always hard to capture slopes on the video or pictures, but if you compare to the trees in the background, you can see that there is quite a bit of slope going there. Pay attention on the right arm. It's making a pause. It's going to hit the rock. Bam, it hits the rock without planting, makes a new attempt and plants successfully. That's one of the functions we have on the machine. This is a typical site in Sweden. Rocks and stumps everywhere. And you can see the arms not always planting. They go down, they realize it's too hard or too soft, and they make a new attempt. This is intermittent scarification, and you can see how the arms are perfectly finding that spot. And here you can see something that shows you the productivity of the machine. This is plus 3,000 seedlings per hour, as you can see the machine. We have this herbicide spray that I told you about. The 3 shelves hold seedlings. We can use a crane and swap storage. You can load from the ground. And that was it.
Right, thank you so much. That was a very, very interesting and intriguing presentation. And good to close it off with a video which illustrates everything that you were speaking about. So thank you. I'm sure there will be some questions and a lot of interest in this. So we will engage on that when during the question and answer session. And now we move on to another interesting presentation. And this presentation is going to be given by Mr. Cassio Gomez, and he's a good friend from Brazil, from El Dorado. So just a little bit about him. He's a professional with a consolidated career in areas of development of excellence, mechanization, innovation of forestry operations in most expensive companies in Brazil. Since 2018, he has been acting as an elective member of the technical board of directors of the collaborative program of forestry mechanization and automation that is with IPEF. And this organization represents 13 of the largest forestry companies in Brazil in collaborative programs of development and operational mechanization. So Cassio, welcome, and thank you for taking the time to give us this presentation, which will be focusing on the latest updates and initiatives of mechanized planting in Brazil. We are looking forward to hear, and since you've been to South Africa, you can make some relevant comparisons about how conditions are that side versus us. Looking forward to your presentation. Over to you.
Hey, hi guys. Thank you for this opportunity. I really appreciate to join you here in this great event today. I hope that you are seeing my screen. Is it right?
Not yet. We still see you, but not the screen yet.
And now?
Yes, yes. Now it's showing.
Okay, thank you, Muedanyi. So, I prepared this presentation just to give you guys the last initiatives and updates of mechanized planting here in Brazil. We have a lot. And there's some different that it's good to present to you for understanding that's not easy for the developers and the companies that have been putting effort in this way. Okay. Muedanyi presented me very well, thank you. I'm Casio. I'm forest engineer, and I have a master in agro engineer here in Brazil also, and some other graduations also. I had worked in Suzano, Klabin, Senibra, and now in Eldorado, Brazil, in front of the development area. I believe that these 4 companies is the biggest one that we have here, and there are some great difference between these 4 companies regarding the slopes, the site conditions, and it is, for me, was a great experience to learn a lot in each one. So I don't have so much time to explain, but I'm a part of IPAF collaborative program now. In other opportunities, you can present it. And I choose some topics to present you. And here I put this image to compare where we are in Brazil and where you are in South Africa. We feel like cousins. We are too close. And when I was in South Africa, I saw some typics so close that we have here in Brazil. So about the presentation, I selected just an introduction about the Brazilian forest sector, a quick overview of planting machines and its development stages, and the tech challenges that the planting machines have to beat. Okay, introducing the Brazilian forest sector is good to show you that we are responsible for around 3.7 million directly jobs in Brazil. Okay, the sector, the forest sector, and there are some projects aimed to increasing the plantations here. And in 2023, we are expecting around $10 billion in investment. I present a little bit more. And in our planted forest distribution, we have 36% of pulp, 12% in steel industry, 6% in wood panels, 10% in plantations with investors, and 29% by individual producers. Okay, the other one is not representative. About the Brazilian conditions, we have the temperature, the average temperature that we have here is around 20 to 26 degrees in the most expressive areas in the plantations. The precipitation that we have in the areas that we have more forest plantations is around 1,300 to 1,900 millimeters. Okay, and the AMI that we have here in the sites is represented in this map is around, the average number is around 40 cubic meters a year. The distribution by state, the most expressive plantations in Brazil today is in Minas Gerais. Okay, in this box you can see eucalyptus, this pine, and these others. The total is represented in these green boxes. Okay, and the most expressive area now that we have the initiatives in Mato Grosso do Sul. This is a comparison between 2022 and this represent today. We increased more than 400,000 hectares planted in 1 year. All the great companies investing a lot in this state, but is a term to discuss another opportunity. I bring to you guys a book that was launched this year during the expo. I'm involved in this organization in IPAF, and this is a great material that share the level of mechanization in some companies, the most expressive companies here in Brazil. These are the companies that is involved in this index, and we selected some stages here in manual operations and mechanized operation in its levels. It's good to present it this because I bring to you this table, and it's good to compare soil preparation and planting, because you can see that average number is around 80 to 70% and full mechanized operation when we are talking about soil preparation. And it's important to describe also that in this comparison, we have companies working in flat conditions and steep slope conditions, and the number is not full mechanized because there are some companies working up 45 degrees that is so hard to put the machines. I'm working in a company that we are ripping the soil full mechanized up to 35 degrees. And we try to use spider excavator to go up to 45 degrees, and we decline it to go up, and then this inclination we reserve it to restorations and native forestry. Okay, just some explaining. And when we present the planting, you can see here that we are in manual operations. Yeah, we don't have so expressive machines working today. We are trying to go in this stage like we have the soil preparation, and I will present you the initiatives to go as quick as possible to this level today. And what we will see in the future is, because Brazil is increased the forest basin, and here we have some announced projects, industrial project, and Suzano is finishing this project now, this plant mill now, that will need around 10,000 cubic meters per year to start support this operation in Eldorado, Brazil, where we are now. And also this other line in the same plant mill, that the reason that I'm here today, we are duplicating the plant mill now, and we don't have labor to support the forest operation and to have a great project to mechanize everything here. This is some others, and it's good to study about this moment in Brazil. About the main issue that we prepared today is the planting machines. Before to present the further, it's good to talk about the previous concept. I saw some images in the other presentations, but all the previous machines had the same concept, to use agricultural tractor and then implement with the person seated in the back, feeding seedling by seedling each time. And there's a wheel that compacts the seed in the ground. Okay. This concept, there are some main limitations. That is the labor ergonomic in the back and some safety conditions here in Brazil. There in Brazil, we have a lot of safety cares to organize, and it for us is so important to think about the people. And of course, the forestry limitations side can also will impact this concept, and this kind of machine is more directed to the implantations, converting meat production or soybean or sugarcane plantation through a forestry operations. Okay. And we don't have strong after-sales support. I heard about it in other presentations today. We are so big companies. We need to have great support and staff, because we have a lot of machine working the same time, working the same site, and to have it is so important for us. This kind of machine also is only for flat condition. There is no technology, and some companies decide to discontinue the production. So about the new concept and the available for sale on the market. First of all, the Komatsu triple planter D61, long famous around the world because it was the first semi-autonomous machine in the entire world to plant. And this is a interesting project because it involved some companies in Brazil, and Komatsu take care to integrate technology and other things to give us data and performance. Okay, I would like to say that today I will not explain about quality and performance and what is the best machine. I really want to say what is happening today. I believe that in another opportunity I can go deeper, because unfortunately I don't have time to go deeper because I have a lot of page to present to you. But this machine is limited only for flat conditions and don't need a person supplying the seedlings. Okay. So in Komatsu, in Braki group, today we introduced this machine for slope conditions that integrates 6 operations at the same time. I was high involved in total program development on this machine. This machine is so inserted in the biggest companies in Brazil, like Suzano, Senibra, and other ones that needs to reap, fertilize, irrigate, and plant. Is interesting in machine because can give everything the seedling needs. I will explain some technical recommendation in the end of this presentation, but it is a machine that can go up to 35 degrees, planting, reaping, and giving data. And for some flat conditions, not too flat, but up to 20 degrees, we developed this machine. I also was involved in this development that give the same operations that the other one, just without the reaping. This machine will plant in reaping conditions. You can see the pictures here. Planting, irrigating, and fertilizing the seedlings and give data. We also developed a system that can have a self-movement for pre-planted sites. It's a double planter. The name is the double planter P22 Braki, and the other one is P12B. And this is the other commercial machine from Uruguay. Is called Jota Hartwig, and this machine looked like the previous concept. Needs a person sit here, 2 persons sit here, and it's quite limited because is only directly to implantations, and the same reasons that I explained it in the previous concept will hit this one. But these machines is already available in the market and is used in Argentina, some places in Paraguay. In Brazil, we try to introduce it, but at now the initiative is not running. Okay, some companies decide to stop the operation with this one, but it's good for you understand what is happening. Plantma, as Christian explained very well, Plantma is investing a lot here in Brazil. There's so many companies interested in this concept. These pictures is here in Eldorado, Brazil. Okay, we tried this machine for 30 days here in the beginning, and there's some things that we understand that we need to improve, but Plantma is working hard in this way. I believe that the next prototype that is under development can solve the bigger ones. The main thing here is to insert a ripper instead of the disc, because here in Brazil it's not often to use this kind of thing. Okay, but like I told, my proposal is not to talk about what is happening, but to present you that have this initiative here. We just introduced here in Brazil the Risutech. I believe that for you it's more representative than Brachy in South Africa. This is the first machine here in Brazil, running trials in the south of Brazil. The concept used the same concept that we developed for Brachy, and then they install the head in the machine. This is the first company trying. It's a Klabin in the south, planting pines, and they will compare the numbers. It's quite the same. They think that they need to choose maybe is about the support after sales, because the cost and the productivity could be the same. The quality, I believe that Risutech can go in the same level. They don't have now, because when we introduce a machine in a new area and we need to develop, to fit a lot of things. Okay. This is the machine that is available or in the final stage in development. And there's another group that is under development that will be launched in the next coming days. The first one that I bring to you is 8D Plan. Is a small company. It's a Brazilian small company that decided to develop and implement. But the concept that they choose here is different than the others. This has a slide in the platform, and the quality that we found here is quite better than the other concept. This is the first prototype that we tried in Eldorado, Brazil, and now the company is finishing the second prototype with some improvement. The big difference is that this first one was mounted in a tractor, and this will be tracked to feel better to the soil. Okay. Another famous project that we also tried here that is under development yet is the John Deere New Guinea. They tried the first concept last year. We tried in Eldorado also. and the second prototype already is in Brazil, okay, running some fitments before to go to the trials, and we will receive it to prove the quality and performance in the field. The concept this machine use also is to slide, put the head in the ground and slide, like stop it, and this machine can plant, irrigate, and there's a lot of technologies into this machine that I prefer that John Deere bring to the market, but there's a lot of engineers involved in this machine. Okay. There's another project that I don't have authorization to present any pictures today, is the novel equipment Ponce that is already ready, the concept, and the first prototype arrived in Brazil this year to start the trials. Okay, maybe novel equipment Ponce will present to the market all the data. I'm involved in it, but unfortunately I don't give information. I don't receive the authorization to give you information, but it's good to know that there is a South African machines running here in Brazil. Another concept that is in the finishing is the forest bot. It belong quite famous because other prototypes was in the social media. The investor from Muedanyi Ramantswana presenting, give a lot of information in the newspapers. But the first prototype will be finished in the end of this month, and we will start the trials in the field. They can integrate planting, irrigation, ant control, pre-emergent spray. There's a lot of equipments that we can choose to use or not into this machine. And you can see that they are using self-propelled, like a base machine. This is the first company that choose this one that I saw. I really recommend to adjust this machine like we have been doing in spraying. We reduce the center mass, and we choose the wheels and the tires for forestry models. But this machine will start in this way, then they will improve in the next stage. Another brand that is in the final here is Semac. Semac is a company that is investing a lot. There's an investor that loves the sector. And the first prototype was launched, but not go to the companies for trials. After some visits, we identify some requirements to insert in the machine before to go to the trials, and the developer and the company is introducing it and trying in the backyard, in his backyard. And we believe that we can have this machine running in our fields in the end of November or December. Okay, the one thing that is good to share about this machine is because this machine is purpose built. The manufacturer produced the base machine and the implement, and you can fit all you want. And they have an electric engine in each wheel. They have a diesel engine, like a generator, and the machine moves and generate power by electric is a new concept that we can see in some agricultural machines running in US companies. Another innovation that you can see in the next coming days is the Rhizotech, a new concept like the plant they are introducing a machine to plant in 2 rows, high storage of seedlings that, and in this case the difference is because they also will offer irrigation and some differences in the seedling compactation. This machine will start trials in the end of this month. Unfortunately, I can't be there by the other commitments, but I will go there after these trials, this first launch, and we are arranging to receive this machine here in Brazil also, to try and compare with the other ones. And what is the challenges for these machines? Here in Brazil, you saw the maps. We are so huge country, and we have so big difference between the companies, and I'm presenting here really technical recommendations that I saw and I tried to do in some companies. And here you can see 2 different fertilizing in the depth. I'm talking about 14 and 13 centimeters in depth. Some company used to put side fertilizers in depth also, each side. Other ones use only 1 fertilizer, and other ones do not irrigate or do not have some basing to support water around the seedlings. And like you do in South Africa, we can see in the south of Brazil some spot reaping or pitting, irrigating or not, using fertilizer in the depth or not. And it is not easy to integrate in one machine, in one model only. This is an example of the reaping system that we have. This is a picture in Eldorado, Brazil. The system that we introduced this year there is a self-pilot machine doing 2 types of fertilizing in the depth, giving so good quality in the top. But when you see the planting machine, this is a picture of a 2 arms plant machine that we try in Eldorado. Look this, the planting line is missed and in only curve. And it is not easy for machines that there is articulation in the middle. When you shift the direction, the back don't cover the same line. And for this reason, we need to develop some kind of machines when we have repeat lines. Another thing that we are seeing here in Brazil is because the tolerance for drown and stand variate between the region and the clones that we are using. And some machines give like a little mound in the stern, and in some regions it's not allowed. There's no tolerance. You can have only 2 centimeters up to the roof, and the other variations is not allowed anywhere. I mean, another thing that is not easy to introduce is the pots. I tried a lot of types of pots in some companies, and some companies approves and some others not, but it's not about the pot, but it's about the site condition, and this is also a subject to discuss in more than 1 hour. But I also bring to you some initiatives that we have here. This is Elapot, so famous around the world, but here in Brazil we have these two another brands that is introducing different types of solutions for you. And what's the big trouble? The big trouble is because sometimes we don't have strong roof or compacted roofs, and the machines broke it during the process, and it will damage the roofs, and the quality will be compressed also. Also, the seedling qualities, we have bad seedlings, no good roofs, we have different sizes, and sometimes we have some quality support in the roof also. The water, some companies need to use water, around 4 liters for seedling, each seedling. Some companies, like I explained in the paper pots, and do not allow to use gel, is another subject to discuss in another presentation. And some companies do not request the irrigation, and it will impact a lot the process, because if you need irrigate, you need to stock water, and depending the performance of the machine, the refill will impact the operational time, and you reduce the production in the end of the day, and your costs will go higher. And to decide to do irrigate separated or not depend of your site condition, of course, and there's no only way. And to the end, I give this image that I saw, and it for me is quite interesting, because if you are doing good in the past and the cost is okay, you can stay here. But here in Brazil, we can't do this because we don't have labor, we don't have support to sustain, to guarantee the production, and then we need to think in the future. And for these reasons, we are seeing a lot of initiatives in this, and there is no one that is the best. Like I presented, the technical recommendation will give you the right way, and for this reason, you will see some companies choosing one type of machine, and another companies choose another type of machine. And I'm feeling it in the day by day, and it is have been a great pleasure to be involved in all these initiatives that I've presented here today. Thank you, guys. I'm sorry for the time. I really want to present to you a lot of information, quality, performance, all the information that these machines already have, but I believe that Muedanyi need to give us more time, the next opportunity. I believe that I pass a lot of the time.
Yes.
This is my contacts if you want more information.
Thank you. Thank you so much. Thank you for that comprehensive presentation. I really enjoyed the presentation and the detail that you shared with us. Very, very important information that we are supposed to have. And we are going to engage now in our Q&A as we get to a close. And I would invite all the presenters that presented in this session to just be available. And then I'll pose some questions to you as they are in the chat, and then I'll give you an opportunity just to respond. So I would like to perhaps start off at the very beginning here, and let's start with the question here is very interesting technology from the nursery space. The precision and productivity is amazing. What is the survival percentage when robots are used? I know it's a bit of a difficult one, but any comments on that?
Well,
that's from
Sibusiso already. Sorry?
I was just saying the question is from Sibusiso.
Okay, yeah. Well, of course, there are many forces at play here, leading to a less waste, higher survival rate, of course. So, but in general, I think we could say that what I've seen at nurseries, it is common that there is a waste of around 30, between 25-35% between the amount of cuttings harvested and the amount of seedlings delivered. That is huge. Significant amount of that is in the first stage, first selection, rooting, and then just after rooting again in the second selection, you see the waste. And the critical causes in that stage, what I've learned is that if you don't plant a cutting centered in that substrate cell, or planting too deep or too shallow, those are the key causes for waste. And that is simply a human tolerance, which is difficult to compare with an automated robot that has always repetitively the same I call it depth and location. So I think it would be fair to say that we can at least improve by 25 to 50% in that first selection. That would mean around, I think, 20-25% of total reduction.
Okay. Very good. There were a couple of questions here from for Mr. Swane, and I see a few of them he has responded to. But perhaps I can just pose this one, which is a summary from Ruben. He's basically asking, why exactly did you go for this machine, considering productivity and everything else? Why would you consider just going for this specific machine? Mr. Swane, you can just unmute.
Well, we went for this particular one, looking at our terrain, and also they did the research, and also when they're willing to sell and make a trial in Africa, I think those tech were up, and they agreed that I can come and see how it's operating, and it just came to our terrain here in Swaziland.
Okay, that's thank you for the response. Perhaps let's go to Krista. There is one here which says, this is also from Sibusiso. He says, very good productivity from the planting machine. What is the capital cost? Is it possible to have a tractor drone implement? And I suppose they are maybe referring with the carrier that is now mounted on the forwarder.
Yes, if you look at the complete machine, including the carrier, the end user price is around 1.2 million euro.
Okay. And if you look at the adaptability of the forwarder and perhaps having that on a tractor, I think that is his question, over and above is to, could that be possible at all?
Would it be to plant on steeper slopes than we had in the presentation, or what is the purpose?
I'm not sure. We can maybe get further engagement from Sibusiso on this question, but I suppose it's just thinking more of adaptability in terms of mounting it on a tractor type system.
Yeah, Mr. Muedanyi.
Yes, Cassie.
Now, I will. I really appreciate this question because it's a dream for me to use this kind of concept in agricultural tractor also, because to have a forward like a base machine will increase a lot of the costs in Brazil because we need to import it. I believe that is the same thing that you have in South Africa. The reason to have this question, Kristen, is just to reduce our price, and then we can save costs. And I agree in your comment. If the purpose is to plant in flat condition, could be good. If you want to try it, I can be at your side, okay?
Okay, thanks for those inputs. And then there's also another question for you, Krista. Is the PlantMax machine planting heads able to plant steady, firm seedlings, or sometimes due to obstacles like rock seedlings become loose or fall apart? This is from Tepo Maipa.
We have different air nozzles that we can alter the duration of, and if we have challenging seedlings, which I can guarantee you that we had plenty of challenging eucalyptus seedlings in Brazil, we can alter those values, and we can shoot the seedlings to the ground very, very hard if necessary, and we can go down very soft if not necessary. So I would say we have a very broad capability of handling different type of seedlings, and we will not have the same damage that we saw on the excavator mounted planting head, because you have only 16 seedlings waiting in line to be planted. The rest of the seedlings are at the stationary surface, either the table in front of the planter or behind him or her in the storage.
And maybe perhaps just a follow-up on that one with another one is, with safety in mind, is there direct communication between the driver and the seedling feeder in the PlantMax equipment?
Yeah, you have headsets you have headsets and open communication between them. Okay.
Back to you. These are questions from Ulrich. He says, is there an easy, non-destructible way to assess a root architecture of plants in nurseries? Clones inherently have poor root systems, and this may lead to increased mortality when planted in field. By assessing root architecture in the nurseries, we might get a better idea of how plants will perform in field.
Yes, very relevant question indeed, especially in particular varieties in eucalyptus, of course, like Duni. We are doing that, as a matter of fact. We are doing that in many other crops. Of course, we cannot look into the substrate, not into the plug. That would require a different technology, and it is possible, but that will, of course, reduce the speed and have it not attractive economics. But looking at root structure of roots, regardless of size, penetrating through the outside of a paper pot, for instance, or in a bare ball root without a tubeter, that is possible, and we can select on that. Done so successfully since many years.
And just another question from Andrew Morris. He says, a automated nursery will require economies of scale. Can you indicate the minimum production capacity that could be practical?
Yeah, definitely. Of course, also here, many variables at play. in general, in say Western Europe and North America, we can say our machines are attractive from 1.5 million cuttings per year upward. But that is with, of course, the wages and other variables here. I'd gladly share some calculation models. So if anybody has an interest in learning how we calculate those business cases, we're fully transparent in that. So just let me know and I'll share that model with you. Economics are astounding. Of course, investment is high. Calculate with at least 200,000 euros upward for a machine with a capacity of 3,400 cuttings per hour. And there are companies here. The largest client here in Holland has 84 machines in one line operating, planting almost 1.6 billion cuttings per year in that line. So if you're talking about scale, yes, that's a scale. Yeah.
Okay, I'm gonna just give two more, and maybe Cassio, you can tackle this one. Have you oh, not that one. Do we see, with all this modernization, the human factor being phased out in the future?
Can you repeat, please? Sorry. I have some disturbance here.
The question was asking, do we see human beings being taken out or not being needed in the future with all the modernization and what is happening?
I believe that it is the purpose. Krista presented some pictures that there are some initiatives in Sweden to remove the people into the field. I tried to use some telematics in some operations, and it works, okay, but also needs a person in the container or in the office to control the machine or to track the machine. The IoT is running fast. I believe that the next coming 10 years, it will be possible. And it is the target of the most competitive company. Maybe Christian will give us a machine like this in the near future.
Okay, I think that's where I will end the Q&A for now. There's an opportunity if you want to reply privately to the questions that are there. You can also do so. I would request the presenters to perhaps just respond to any of the Q&As that have been directed to them. And with this, I would like to just come to the end of the webinar and just take an opportunity to just summarize some of the main things that we had today, because we had a good overview from the very beginning by simply just giving us the different pathways in terms of us considering, yes, the modernization, but also considering potential impacts to local communities given the South African scenario. And she also emphasized on the importance of looking and improving existing tools and methods whilst considering the economic inputs and issues that exist. And he also then came and gave us a good overview of the different residue management methods that were studied, looking at manual broadcasting using a tractor towed mulcher, as well as using a fully mechanized mulcher, and the subsequent growth impacts of using the different system. Mr. Nzele also then focused on an interesting innovation of the thrown-up spraying tractor, which is a highly productive system compared to the conventional systems, and one that one should be looking out for going to the future, especially in your level and gentle terrain. Mr. Hendrik Jenner also gave us food for thought in terms of the importance of using advanced systems that we can use to monitor, as well as improve the data collection of our different operations. It provided solutions that Resutech has that can be incorporated to equipment so that one can be able to monitor this, gather this data, and also be able to make decisions in real time or near real time. So Job Hendricks also gave us an interesting presentation about how robots can be used with relative accuracy in producing cuttings, over and above just cuttings, grading and sorting, and the importance of how robots can be introduced to improve efficiency within nurseries that require to upscale and also improve their productivity. Mr. Zwane also gave us an honest presentation about the lessons he learned in introducing the excavator-based planting machine, as well as the opportunities for further growth and development. He mentioned the issues that are important, such as seedlings trays, productivity goals that they would like to achieve, as well as the importance of having all supportive logistics in place for a mechanized planting system to be a success. Mr. Christa Larsen also then provided us a good overview of the plant mix, how it has been used across the globe in various terrain conditions. And some of the key words he mentioned was the importance of being adaptable and flexible, especially when you are approaching the large scale type of re-establishment with such a high performance machine. And then Mr. Casio Gomes gave us a good overview of what is happening in Brazil in terms of strategically establishment of areas, and then gave us the foundation of where things started from traditional tractor-based planting systems, and then progressed to what is currently being done now with tagged machines as well as wheeled machines that are being used. But of interest is what is coming. All the interesting innovations that we can expect within the in the future, and the applications that can be introduced within the forestry industry, especially in the area of mechanized silviculture. So I would like to take an opportunity and and say thank you to our presenters. I know it's never easy to prepare these presentations and consolidate, gather the information, and of course speak to a crowd of people across the world. So I would like to thank you for taking time to present at the Nelson Mandela webinar, which focuses on modern silviculture technologies. And I would also like to thank our department, which is the Forestry Department, for supporting this initiative. I would like to thank Prof. Chentu, who's our Deputy Dean of Science, who did the welcoming. And most importantly, thank you to the attendees. We had a resounding response, which shows the desire and interest from different people to learn about what is happening both locally and globally across the silviculture value chain. So thank you to the attendees for logging in and learning. And to those that posed questions, thank you for being active and participating well. And I'd like to thank Umlani, our IT technician, as well as the rest of his team, with Holly, who oversees all the IT team in the George campus. And thanks to Tiffany, who has also been supporting us in terms of setting up registrations. Thank you to Melissa Pico and Monica Changana from the marketing side, who helped us with the advertisements, and to some of the honor students that were involved in the background, such as Henny Zita, Temikosi Zulu, and Junior Koza, who were very, very instrumental in ensuring that this webinar takes place. So in terms of the presentations, quite often we receive inquiries at the end, are we able to have the presentations? So with regards to that, we will inquire from the presenters directly if they give permission to share the presentations, or limited parts of the presentations can be shared. And once we have that permission from them, we can then share with you. So details regarding the next webinar will be shared in due course, but we are quite excited about next year and what will happen. And lastly, I would like to just conclude and say, if you have any suggestions on how we can improve proposals of interesting areas that we can focus on going into the future, please feel free to communicate with me directly, and we will really appreciate your inputs and consider them in developing the program going into the future. For today, we'd like to thank you and wish you well and have a good day further. And bye-bye.
Thank you.
I would like to request the presenters to just remain briefly for just the group photo, then we will proceed.